So. Ja. Ho, ho. 1, 2, 3. So, so, so. Ja. Ho. Ja. So. Ha. Ja. So. Ja. Ho, ho. 1, 2. 1, 2, 3. Ja. Ho, ho. Ja. So. Ja. Ja, ja, ja. So. Ja. Ha. So. Ho, ho. Ja, ja, ja. So. Ha. 1, 2, 3. So. Ja. Ja. Ho, ho. Ja. So. Ja, ja, ja.
We're developers.
Working in games, like basically any form of tech, you're gonna find those people here. So I had a blast.
And I could tell that pretty much everybody played Doom that was in the audience. So I was talking exactly to people that knew what I was talking about. So that was was nice.
So even if you're not a techie,
I want to have, and I want to learn more about that.
It might seem crazy what I'm about to say.
know. How many of you went to the party? Oh. How many went to a party? Okay, how many of you drank last night? Oh, more hands. Right, so I just want to find out how you are this morning and where you're at. So we get your Slido.com. Get your Slido out. I know you've got devices. And we're going to ask you a question. So, can we put the question up? I can't remember what it was. We got it? So it's basically, how do you feel this morning? Did you drink last night? Okay? Have you got it? Yes. Oh, you've got it? Oh, you've answered. Oh, you're waving. Okay. Okay. So, word cloud. Have you guys got the question on your Slido? Main stage? No? Is it that bad this morning? Are you really struggling? Okay. I need to get some energy. Okay. So are you hungover from yesterday's party? I wasn't there. Okay, no comment. No, I didn't drink. Yes, but it was worth it. There's not many of you, yes, but it was worth it. Like 64 people have responded. Let's see. Oh, I wasn't there. Ooh. That percentage of yes. Oh. Okay, keep answering. Okay. Because I know that Friday morning is always a little bit of a challenge. I'm just going to ask you to stand up one moment, literally, one moment. Stand up. Okay, we're just going to put our arms in the air. We're just going to lean over to this side, okay? Lean to that side. If you can, touch your toes. Okay, let's see. Hear the creaking. Okay, and we're just going to put our arms out. Come on. Don't hurt the person next to you. All right, and up again. All right, let's go over this side again. Woo, and this side. Oh. All right, let's take a deep breath. In and out. One more. In and out. Okay, are you better? Are you in the room? Great. Woo, woo! Okay. We have an action-packed lineup for you today. There is lots to do, lots to see, lots to experience. So, guys, if you're coming in, come on quickly because we're going to move on. So, this morning's opening keynote speaker is a best-selling author, speaker, educator, and one of the world's most foremost Bitcoin and open blockchain experts. He's a teaching fellow at the University of Nicosia, serves on the Oversight Committee for Bitcoin reference rate at Chicago Mercantile Exchange. Among other things, he's authored 4 books and 300 plus hours of educational videos about open blockchains, all of which, and I think this is phenomenal, all of this are all available under open Creative Commons licenses. That's access for you. So, what a lot of people don't know is that his first business was actually a pirate radio station in Athens, which he started at the age of 15. Now, as you know, I've asked all the speakers what their one phrase to live by is. And his is a phrase coined by Richard Feynman, and it says this: if you can't explain something simply, you don't understand it. So please, join me in welcoming to the stage Andreas M. Antonopoulos.
All right. Welcome, everyone. Thank you so much. What a great welcome. I don't know if I can keep up that level of energy. I really like that demonstration of the cognitive and statistical biases of selection and survivorship bias. Are you familiar with these concepts? That's when you do a poll about how drunk were you at the party yesterday, and the only people who are here are the people who didn't go to the party yesterday. So your results are skewed. Where are the people who are hangover? They're not here. So they can't participate in the poll. So those results are not very scientifically accurate. I love little statistical tricks like that. I'm so happy to be in Berlin. I'm so happy to be back at We Are Developers and speaking to you today about trust and security in this new model that we have using open and public blockchains. When I say security, what comes to mind first? Is it a lock? Is it a door? Is it a wall? Is it a safe? You think of physically restricting access. Maybe if you're an information security professional, when I say security, you think of a firewall, an inspection device, systems that control access. When I say trust, you probably think of a friend, a person who's dear to you, someone who you have a personal connection. We associate trust with people who are in our local surroundings. And when we try to engage with more people than our local surroundings, our brain starts playing weird tricks to us, just like the statistical bias I talked about before. We trust people who have the same background as us. We trust people who look like us, because evolution has taught us to trust our tribe, because that's a mechanism for survival. And in a modern society, that type of cognitive bias leads to horrible outcomes. Racism, sexism, discrimination, ageism, ableism. You start looking at people and making judgments about trust because your brain is wired to make these mistakes, to use these shortcuts. It's an efficiency machine that does pattern matching. And these patterns are easy and obvious, and you've learned them from birth. It's a very bad model for trust, and it's the only model we have. So when we operate in a society that's greater than about 100 people, we have new models of trust. We have to find other ways to engage with others, other ways to trust, to extend trust to a bigger circle. And what do we do for that? We use intermediaries. We use trusted parties. We trust our bank to protect us from somebody else's check or payment bouncing. We trust authorities. We trust organizations and institutions to operate through a series of rules and policies and build trust for us through that institutional model. And that model is flawed too. It scales a bit better, but it does something very, very dangerous, which is it gives power to that intermediary that acts as our trusted third party. It gives power to the financial services companies and banks that act as intermediaries of trust. I'm Greek. That trust doesn't go very far in my country. But my country is not unique. I can name 24 countries that currently, if you say, trust your bank in an audience this size, the laughter will go on for at least 10 minutes and I won't be able to finish my talk. Trust your government. Germans can say, jawohl. 80% of the world goes, ha, 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 ha. I'm not going to trust my government. They're a bunch of crooks. Probably worse than the bankers they appointed. Trust in intermediary institutions also doesn't scale. It doesn't allow us to solve the global problems we need to solve. Each of these institutions has a narrow jurisdiction. It can only operate within the confines of one country, and the norms are different in each country. So trust doesn't scale with the models we have. It affords too much power to the intermediaries, power that corrupts and leads to them abusing this power. Ask someone in the US how they feel about trusting the police. You don't call the cops in the US. They're more likely to shoot you accidentally than to solve the problem. Trust in power is a dangerous thing in a modern, scalable world and a globalized economy. let's think about the models of trust we've got used to for years and the model of security we've had for years. If you visit European cities, you will see one of the tourist attractions is to visit one of the gates, the Brandenburg Gate, or maybe a gate that's at the outskirts of Paris, one of the 11 gates or how many there are that ring Paris. Do you know what those gates are? They used to be actual gates in the medieval wall that surrounded the city. In medieval cities, a wall was security. That's how you keep the barbarians out. You build a wall. The Great Wall of China, the Great Wall on the US-Mexico border that will never be built, and thank God for that. Walls are the model of trust and security that we've had for millennia. And walls fail. And the reason they fail are not because of ladders, although that's also a use, or catapults, or airplanes. The reason they fail is because of trade. Because if you build a wall, you need gates. And those gates need to be open most of the time so that people can come into the market and sell their wares. And if you are under siege and you close the gates, you have a matter of months before everybody inside starves. And if you close the gates because you don't like the people who are outside, the really interesting and vibrant market will be the one that emerges ad hoc right outside the wall. Your marketplace is now outside, not inside. Walls have failed in our modern society because of trade, because we need to move people, move goods, and move value in and out of these globalized cities. So what do we do when we create an information economy on the internet, when we create a new environment for us to trade ideas and trade goods and trade value? We make walls. Only this time, we imbue them with fire, and we call them firewalls, which is very impressive sounding until you actually see one, and it's just a black box with one LED. And what does a firewall do? It creates a barrier to entry, and it replicates the model of a medieval city. You have an inner core, a trusted center, where corporate data goes to die, to become stale and useless and uncollaborative and unshared. And there's a very nice firewall protecting that core data, but you can't actually use it. Because in order to use it, in order to share it, in order to collaborate, you have to open a gate. And as soon as you open a gate, all of the bad things flow through the gate together with your employees, who went on a vacation and took their laptop with them and came back with 17 Trojans, 3 viruses, and a porn toolbar. And now they put that laptop right inside your corporate firewall, and guess what you now have inside? The barbarians are through the gate. So what do? Do you close the gate? No, we build concentric circles. An inner circle, a medium circle, a bigger circle, an even bigger circle. You have your corporate confidential data, then you have your intranet, then you have your wiki, a bit broader, and then you have the open public systems. And just like in a medieval city, when you close the gates, the market ends up growing outside the wall. All of the interesting things, all of the value creation, all of the content, all of the open source code, everything is happening outside your walls, outside your firewall. It's happening on GitHub under open source licenses. It's happening on Wikipedia. It's happening on the great open spaces of the internet. And your company isn't participating in any of it because you're too busy hiding behind the wall, scared to connect to the broad internet. When I started consulting about the internet in the 90s, this was the biggest challenge to explain to companies. And they would ask me, how can we open ourselves up to the internet? The internet is full of pornographers, criminals, terrorists, and scammers. And so here we are today, and we now have a new model for trust and a new model for security. And this model is not closed, and it doesn't use walls, and it doesn't use gates. It's the open public blockchains. And they develop trust by giving a platform that can mediate without being under the control of any organization or institution, that allows individuals to scale their trust to people they don't know because they can trust the rules of consensus, not each other. And they will have settlement of their transactions and verification of their data by a neutral platform that is not controlled by anyone, by an open, public, transparent platform that is not controlled by anyone, by a censorship-resistant platform that even though totalitarian states hate, they cannot shut it down. They cannot stop it from operating. You can't take Bitcoin out of your country, but you can take your country out of Bitcoin and not share in the benefits. And that applies to every open public blockchain. These are resistant to censorship. They're resistant to control. They give us a transparent platform where we can build trust. Trust between individuals, trust between organizations that are collaborating, new open forms of collaboration, ad hoc companies, decentralized autonomous organizations, work collaboratives, charities that are transparent and allow us to track the spending of money across the world, international payments across borders without controls, without censorship, without the privilege that all of us in this room share to not only have a bank account, but even more importantly, to have an ID that is well documented and to be a full member of a society in which we are not a hunted illegal immigrant or a refugee or a suppressed minority or a woman in a country that is not allowed to own property. And the blockchain sees none of that. It's completely invisible to these platforms because they are neutral. So instead of a model where we have a closed center, we have a model where everything is open and public and auditable by everyone, where security emerges not from the control of one institution, but from the collaboration of tens of thousands of nodes, each checking every result to verify it, and each coming together in consensus to say, this is the truth of the last 10 minutes. And I can't control it, but I can verify it. This model is going to change how we do trust and security across the world. It's going to change how we do collaboration across the world. It's going to change the nature of the modern corporation. It's going to change the nature of commerce and trade, because for the first time in human history, every human being on the planet has access to financial services without asking permission, without showing identity, without having to belong to a certain class or status, even if their government doesn't want them to have that, by the simple installation of an application. Software is the new form of banking. And a lot of you may hear the idea that these open blockchains are about making a one world currency. That could be nothing further from the truth. Or about allowing everyone to be banked without a bank. Or to bank the unbanked, those who do not have access. And I'm here to tell you that what these platforms are here to give us is a choice to engage in a platform of trust through consensus that frees us to trust many and to scale our social organizations to massive levels and engage with the entire international population of humanity without barriers. It is not about banking the unbanked. It's about unbanking all of us. It's not about creating new trusted institutions. It's about creating trust without institutions. Trust through software, trust as a protocol, trust over IP, TIP. And what do the companies say when you tell them, there's this new trust platform, you can put all of your trust parameters and use this trust protocol in an open, public, transparent, neutral way? The same thing they said in 1995. Isn't that the platform that's being used by drug dealers, terrorists, pornographers, and scammers? Yes, it is. Just like the internet. And it's also being used by 2 billion people sharing cat videos. And it's also being used by thousands of people today, hundreds of thousands of people tomorrow, millions of people the day after, to provide to their children sanitation, education, and a future that cannot be confiscated, cannot be seized, cannot be currency controlled, cannot be shut down by every totalitarian government. It gives people voice and freedom of expression. Because without the freedom to transact, without the freedom to associate, your freedom of expression and your freedom to vote means absolutely nothing. If we go to a world where digital cash is the only cash that exists, if we eradicate cash, as so many governments are trying to do, if we eradicate the ability to transact anonymously, individual to individual, every government that controls that system can turn off your economic life by flipping one bit. You went to the wrong protest, you voted for the wrong party, you talked to the wrong person on the internet, you no longer exist. You have no income, you can't buy food, you can't travel on the trains, you can't take a plane. You think I'm exaggerating? This system exists today. It's called Sesame Credit. It's being trialed in China. It has excluded 100 million people from using public transportation and flying across the country. It denies people access to fundamental services by virtue of how politically they engage with others. Every country in the world that gives this ability to a government is one bad election from losing their freedom forever. We have a choice. We are at a crossroads. And in this crossroads, we have to pick between a future where trust is a decentralized, open protocol that everybody participates in, or a future where trust is controlled by narrower centralized interests that use that to control our lives and to prevent us from engaging with each other, that create tiers not just of citizen versus non-citizen, but of human versus subhuman, where people are judged by their credit score as unworthy to participate in the global economy, by their lack of identity as unworthy to participate in commerce. And you know what open public blockchains like Bitcoin say? Everyone is worthy. You don't even need to be human to participate. Software agents can do it for you. There is no requirement for ID. There's no requirement to even prove you have a heartbeat. On the internet, no one knows you're a dog. You remember that expression? On Bitcoin, no one knows that your dog is a millionaire. Maybe not. But it's a really interesting future we're building here. We have now, for the first time in history, the ability to scale trust and security to a global level based on an open protocol that no one can corrupt, co-opt, take over, and control. And with that model, we can seek freedom, we can build tremendous applications, software that is unstoppable, speech that is uncensorable, commerce that is not able to be deplatformed or silenced. We will take back the internet from the companies that can decide that hate speech is okay, but female nipples are terrifying to our children. Do you know what's terrifying to our children? Fascism is terrifying to our children, not nipples. They have a more intimate and natural relationship with nipples for the first 3 years of their life, at least. We should be terrified about the future of our children, but not because they're going to be exposed to nudity, but they're going to be exposed to radicalism. And those same companies that adopt their puritanical morality that you didn't vote for and doesn't match your interests don't give a shit about the environment. They don't give a shit about environmentalism. They don't give a shit about LGBTQ issues. What they do, they put a giant sign with a rainbow that says MasterCard on it. Are you fucking kidding me? Those companies are selling us a fake morality that had been focus grouped and delivered to us packaged in a dopamine-engaging algorithm that will tweak our brain until we are mindless drones. We will take back the internet. We will take back our data. We will take back our privacy, which is a fundamental human right. And we will do all of that by building absolutely unstoppable platforms and protocols for the next frontier in trust and security. Thank you. Thank you.
Damn, I left it.
I get a bit worked up about stuff like this. I get a bit emotional. I hope you feel it the way I feel it, because what I'm talking to you about today is really important stuff, and it's real. This isn't some marketing bullshit. Let's do some questions. If you have a question, we'll get I believe we have an app for the questions.
Yes, we do.
Let's do it.
The Slido should be coming up. And I left my tablet, which I'm just being grabbed. If you give me 2 seconds, I'll grab my tablet. 2 seconds, everybody. OK, it'll take me a bit more than 2 seconds. Thank you.
You know what? I'm just going to start answering. Could quantum computing break a private key in the next 5 years? Not in the next 5 years. Possibly in the next 10 to 15 years, quantum computing will deal a serious blow to all encryption systems that depend on the discrete logarithm problem. And that includes not blockchains, it includes nuclear weapon triggers. It includes the communication of submarines and fighter jets. It includes the command and control systems of every government in the world. You think blockchain is a problem? Every system of encryption is a problem, but that's okay, because we can upgrade them. Cryptography fails every 15 years to be replaced by cryptography that will keep us for the next 15 years. It's an endless arm race, which we cannot win, because each development invalidates the previous round of cryptography and creates a new one. Can quantum computers break the blockchain? Yes. Can quantum computers be used to secure the blockchain? Yes. So how do we fight quantum computing? With quantum computing.
OK, thank you. The blockchain ideology is good on paper, but it's still regulated from the government and not so anonymous in real life. So why should we trust blockchain?
Well, that's a really good question. There's a big misunderstanding here. Open public blockchains are not regulated by any government. They're regulated by open mathematical algorithms. The government does regulate the endpoints through which you may use for example, an exchange to treat these open public blockchains as a get-rich investment scheme. And if that's what you're doing, the government will regulate the points at which you exchange fiat or national money for cryptocurrency, if we're talking about payments. Now, let me ask you, how many people in this room have bought euro from your bank recently? Oh, you don't buy your euro? You earn it with your labor. Well, I don't buy Bitcoin either. I earn it with my labor. And guess what? There's no regulation when I earn it with my labor. Nobody tells me what I can and can't do when I earn it with my labor. We're talking about building a parallel economy here. The bridges to the old economy will be regulated by governments. Let them have it. Let them put guards at the gates of a system that flows like water all over the planet, that exists everywhere all the time and has no location. Let them try to build walls. We will laugh at them.
Okay, so how does blockchain prevent a government seizing my house that belongs to me according to blockchain consensus?
It doesn't. There is this really interesting thing that happens when the physical world meets the blockchain. Blockchains can control and verify things that are intrinsically managed by blockchains themselves. A lot of the use cases you hear about blockchain, like tracking oranges or cocoa beans from the manufacturer all the way to your store, are mostly bullshit. And the reason they're mostly bullshit is because I can't verify the existence, trackability, or identity of a cocoa bean using an algorithm. I have no way of knowing. We can put sensors, and the sensors can be fooled. There was this very interesting project where they had sensors inside refrigerated trucks on shipments of medication that were subject to degradation and destruction if they rose above a certain temperature. So when the refrigerated truck breaks down, what does the driver do? Do they admit that they've just destroyed 250,000 shipments of medication? No. They park at the nearest gas station. They open the back. They take a bag of ice from the ice box in the gas station, and they put an ice cube on every sensor in the back of the truck. And all of the sensors say, 4 degrees Celsius, we're doing great. All of the drugs are destroyed. That's what they're tracking with these blockchains. It's a complete joke. If you use this to track physical items in the world, you have counterparty risk. The gold that says is yours on the blockchain is in a warehouse held by someone else, and that someone else doesn't actually have the gold. The copper, the pork belly, the cocoa beans, your house can be confiscated. What can't be confiscated is the actual currency that lives intrinsically on the blockchain, is the intellectual property. It's the proof of documentation that you've put on the blockchain that cannot be confiscated.
Okay. So how are people supposed to use Bitcoin as a currency today when the value is so volatile?
That's a great question. Well, you either take the risk and you understand that over the long term, the downside is bad, but the upside is so great, it makes it better. That's a personal choice, and I'm not recommending that anybody sees it as an investment in that way. I get paid in Bitcoin. I pay my staff in Bitcoin. I get Bitcoin in and out of my wallets every single week. So there's flow through. So if I pay someone at one exchange rate with Bitcoin I got at almost the same exchange rate a week earlier, it doesn't really affect me. The ups and downs, they get averaged away. You don't have to do that. So what do you do with it in the meantime? You can look at it as a store of value investment. You can investigate new technologies that make payments much faster, or you can just exchange it immediately for euro. It's not for you necessarily, because you already have access to financial services. Ask an Argentinian about the volatility of Bitcoin, and they will tell you, as they told me at the first conference I went to in Argentina, they said, listen, the Argentinian peso is also volatile, more volatile in fact. But the main difference is, the Argentinian peso is volatile like this, and Bitcoin is volatile like this. I'd rather be on the other side. And those who made that choice 5 years ago are laughing now. Volatility is an effect of limited liquidity and size, which means volatility is a way of saying Bitcoin is still small. So if you can ask, how does Bitcoin get big if it's so volatile? Let me replace those words in the sentence and say, how does Bitcoin get big if it's so small? When it's big, it's not going to be small anymore. Therefore, when it's bigger, it gets less volatile. And we've seen that in practice over 10 years. The volatility has consistently declined. If you look at it statistically, it's getting less and less volatile. The reason currencies like the euro are not volatile is because they're like a great sea liner that takes 3 miles to make a 5-degree change in course, and even though waves are hitting it from the side, it doesn't move because it's displacing 400,000 tons. Bitcoin, by comparison, is a little Zodiac boat that's bouncing up and down on the waves next to it. Of course, if you're in the Zodiac, you can steer away from the iceberg. If you're in the giant ship and your central bank has blinders on, you go straight into that iceberg and you turn into Argentina overnight.
Okay, so what do you think about Facebook coin?
Facebook coin is PayPal. Facebook coin is not a cryptocurrency. A cryptocurrency that concerns and interests me is a system that is open, public, transparent, neutral, censorship-resistant, and operates without borders. Facebook is a regulated company, and therefore they cannot operate without borders. They cannot be neutral to payments. They cannot be censorship-resistant. They cannot be public. They cannot be transparent, and they cannot be open. They are not a cryptocurrency. They are a severe threat to the banks that do not understand that they're now getting attacked from 2 fronts simultaneously. On the one hand, the free and open systems that will bank the billions of unbanked that they refuse to serve. And on the other hand, all of their valued customers are going to be taken away by technology companies that know how to do technology much better than banks and know how to do user experience much better than banks. And if you combine money with a dopamine tweaking algorithm, Facebook is going to crush the banks faster than Bitcoin crushes the banks. I'd be worried if I was a bank, but I'm not.
Okay, so can you say some more about cryptocurrencies and how they're being manipulated by a few wealthy whales? Isn't that a problem?
I'd like to answer both of the next questions simultaneously
Okay.
because they're very relevant. Don't confuse the manipulation of price and market with the operation of the protocol and network. These big whales can slap the price around by buying and selling the currency, and they do so at great risk. They are representing the exact same corruption and collusion that you see in any financial market. And the reason they do that is because they're not operating on the Bitcoin blockchain. They're operating in the private databases of exchanges where they trade Bitcoin that's not registered to anyone back and forth amongst themselves. This is not Bitcoin transactions. This is not the consensus protocol. But they have also tried to use their hundreds of millions of dollars, billions of dollars sometimes, to manipulate the consensus rules of open public blockchains. And when they did, it ended in tears for them. They lost hundreds of millions of dollars crashing into the immovable wall of blockchain where their money means nothing because they have no control. They are not controlling the protocol. They tried. They failed spectacularly. And we learned a very valuable lesson about how resilient these protocols are.
Okay, so the next question is, isn't the term blockchain in most cases misplaced? Isn't it a permissioned blockchain without an incentive system, for example, mining, not a real blockchain?
The question you should always ask is it open, public, transparent, neutral, borderless, censorship resistant? If it is not, it is bullshit. The highest viewed video on my YouTube channel is called Blockchain versus Bullshit, and it addresses exactly this question. And it explains exactly why these permissioned ledgers, while a slight improvement over the completely centralized systems that banks use today, instead of having one bank in control or one company in control, you could have 5 corrupt financial services institutions fighting each other for control on a permissioned blockchain. That's not an improvement for our global financial system, although it is an improvement for the morass of morality-free trading that happens in the world's financial money laundering casinos. But we have blockchains that are not permissioned, but operate through consensus algorithms that are collaborative. You do not need permission to connect to these. They are using the term blockchain in order to co-opt and stop disruption by pretending to do disruption while doing business as usual. When you tell people there are no leaders in this system, some people say freedom, and some people say, does that mean there's a vacancy for the position? I would like to nominate myself to be the new leadership of this brave new world. We do not change the world of finance by replacing the figureheads at the top with a new set of people who seem kind of nicer at first.
So how do you get non-IT people into blockchain, like your grandmother, apparently?
It depends on whether your grandmother really needs this technology. And I encourage people against trying to promote this technology to people who don't need it, don't want it, and frankly came to this party to enjoy some music, and you've been talking about Bitcoin for 45 minutes, and they're sick of it, as is your boyfriend or girlfriend who gets dragged to the Bitcoin parties all the time. Don't do that. There are a lot of people in Western democracies who do not need this technology yet, and that's a blessing. That's the incredible privilege of living in an advanced society where the banks serve you. They're not outright crooks. Your government isn't trying to kill you. You do have democratic rights, and you have the freedom to choose between multiple providers. Congratulations. You're part of 6% of the world that doesn't need blockchain. There's lots of people who do. Your grandmother doesn't need this. Let's hope she never does. Let's hope she continues to live in the blissful state of a free society where institutions actually work. The other 95% of the planet would love to live like that.
Okay, great. Thank you. So how do we, how can we get crypto with no KYC and no bank account?
KYC stands for Know Your Customer. It is not a chicken branch that sells fried chicken. It sounds the same. KYC is the promise that if bankers know everybody who transacts and they know their identity, the world will be a safe place without crime. The problem is that it's not coupled with the other important acronym, which is KYB, which is Know Your Banker. For example, know that your banker is funding multi-billion weapons manufacturers to bomb and starve children in Yemen. Know that your banker is funding regimes that like to cut up journalists in embassies with hacksaws. Know that your banker is behind the environmentally destroying industries that are making your planet unlivable for your children. But we don't have Know Your Banker regulations. We have given the power to banks to become deputized in law enforcement systems so that they can further exclude the undocumented, the unprivileged, and those who don't have the facility to meet their crazy procedural rules. So, let's drop the KYC. It doesn't help anything. It doesn't solve crime. It simply gives the ability for crime to be committed by those who are licensed bankers. Because if you really want to rob a bank in the 21st century, you get a bank license and you rob the entire country. Deutsche Bank, Greece.
Okay. So
How do you get it without KYC and a bank account? You earn it with your labor. Okay. You exchange it with anonymous people for cash. You offer your services, your passion, your creativity. And in that moment, you achieve two great things. One, you have entered the economy of the 21st century, the free global economy that includes everyone, and even better, you have exited the system that supports and funds war and corruption and environmental destruction. You exit at the same time that you seize an opportunity to enter a new economy. It is a very powerful move. And at first, when you offer your services, products, and creativity for Bitcoin, no one will buy them. Because not that many people you know have Bitcoin. That's okay. Persist. Try it out. Learn. Give yourself the gift of education. Learn about this technology. Experiment with it. One day you'll get a customer. They'll be so happy that you take Bitcoin, they'll probably tip you very well, especially if they're an American.
Okay. So is earning Bitcoin taxable for your labor?
Everything is taxable. Any form of value that you receive, doesn't have to be a currency, is taxable. If you pay me in eggs, I have to declare that on its corresponding market value as a taxable income stream. In fact, if I sell them for a higher value later, I have to pay capital gains on the eggs. That goes for goats and beef and anything else you might sell for services. Nothing changes if you use a currency. I get paid in euro. I get paid in yen. I get paid in British pounds. I get paid in dollars. When I get paid, I check what the market value of the transaction is. I report that as income. If I then sell that currency or convert it into US dollars, if it has appreciated, I pay capital gains on that amount. If it has depreciated, I declare capital losses. I have to do that for every currency in the world. Cryptocurrency is absolutely not different. It's exactly the same. And yes, I pay my taxes, not because I can't get away with not paying them, but because I fundamentally believe in the social compact that says that I want my taxes to go to help other people who are less fortunate than me. Unfortunately, that's not what happens in the US system.
Okay. Let's do that. All right. So, if blockchain encryption breaks every 15 years due to the encryption failing, wouldn't your data of the past 15 years become mutable?
That's a great question. Yes, if you do nothing to protect it. But keep in mind that we see these developments coming, and the ability to break something is not suddenly and instantaneously available to everyone. If these algorithms are weakened by quantum computing, at first, the level of quantum computing that will be needed to break these keys is phenomenal. It is something that will cost $500 billion to deploy, and on doing so will consume nation-state budgets. If you are a nation-state and you have this awesome capability, do you use it to take the Bitcoin from the weird nerds on the internet? Or do you keep that as the most important secret so that if you are attacked by a nuclear-armed adversary, you can simply turn off all of their nukes? Of course you keep it. This is exactly like when the British and the Allies broke the encryption in the Second World War, and they would not act on that secret unless they had a way to show parallel construction, to show that they got the information another way, including letting cities be bombed even though they know it, because if they reveal the secret, it's worth more than saving the city. If we have quantum computing, it will be further decades until it reaches a commercial level where even well-funded corporations can break the keys. And in that case, it becomes a bounty reward to those willing to invest enough in order to break keys that have old Bitcoin that hasn't been moved. For the rest of us, we just move our systems to keys that cannot be broken long before those keys become breakable. This has happened repeatedly in the history of encryption and security. It's not a problem. We keep doing it.
Okay, so is blockchain stroke cryptocurrency bad for the environment in comparison with other forms of payment?
That's a great question. And the key part of that question is, in comparison with other forms of payment, absolutely not. It takes billions of dollars to print paper currency. It takes billions more to transport it in trucks and transport gold and other assets and store them behind bars and pay guards and dogs and cameras and diesel for the trucks and all of these things. Our current financial system costs an enormous amount of money, but most of that is completely hidden from view because it happens in private organizations. We don't see this cost. With cryptocurrency, because it's an open, transparent blockchain, we can count to the joule how much energy is being used by the system in the long run. And using alternative energy sources, because this technology can use any energy anywhere in the world, any time of the day or night, we can not only make this the cheapest form of payment system our planet has ever seen, but also the most environmentally friendly form. And that's not counting the fact that our current financial system allows corporations and governments to divert trillions of dollars into war. If you are concerned about environmental destruction, there is nothing more environmentally destructive than war, and it is financed directly by debt through inflation and your tax money. So take it away from them.
Okay, and for our final question, what do you think about governments and law enforcement agencies trying to track open blockchain?
There are some companies advertising at this conference that do this. They're private companies. It's not governments. They outsource this to private mercenaries who are building surveillance capitalism to destroy the freedom and privacy of individuals, and they're selling this data to the worst, most totalitarian governments in the world. And they are building the technology and making it better and selling it to the worst, most brutal governments in the world. And they're in this room right now. So my message to all of the analytics and surveillance companies that are milking the blockchain and lining their pockets while committing horrific crimes: you are a scourge on humanity. You should be ashamed for every moment you keep that job, blind in the comfort that you're just paying your mortgage and you're just a little part of a giant, invisible, anonymous machine that is destroying democracy and freedom around the world. You should be ashamed if you're building surveillance systems. Thank you. Thank you.
Thank you so much, Andreas. That's so much information there. So if you want to take a selfie or get an autograph from Andreas, then at 10 o'clock, he's having a meet and greet by at the We Are Developers booth. So if you want that selfie or you want an autograph or you want to ask him another question, then please be at the We Are Developers booth at 10 o'clock. Thank you to Andreas. Thank you, guys.
nice mixture of heat, right? And everybody still vibes in, you know what I mean? They're still craving for that, you know what I mean, style of original music.
Right, listen. Time to turn on the bass for the next chapter.
style or original music.
Welcome back, everyone. So our next talk is an IBM double act. One has worked over the last 18 years for development teams in the USA, and he was one of the first developer advocates within IBM and has been an advocate for over 11 years. He now sits as a senior developer advocate for IBM. He's the husband of one and the father of 5 children. His phrase to live by is do what you love. The other is a month away from being in IBM for 30 years, and he switched roles every few years to learn something new every time. He's currently the technical sales specialist in the IBM commercial team. His phrase to live by, you are never too old to start something new. Talking about how to develop your first cloud-native applications with Java, please welcome to the stage IBM's Nicholas Heideloff and Harold Ubele. Thank you.
Yeah, thanks a lot for the nice introduction, Madeleine. And hello, everyone, to our talk, How to Develop Your First Cloud-Native Applications with Java. In the next 30 minutes, we're going to describe the technologies that are needed to build cloud-native apps. And after this talk, every one of you will understand the key cloud-native concepts and will know how to get started with microservices. The topic cloud-native has been around for quite some time. The first time I had to do with it was 5 years ago. It was shortly after I started to work in a new team, a team of developer advocates, and we worked on cloud-related technologies. To be honest, at that time, I didn't know much about cloud computing, which is why I had to learn a lot of new technologies. One of my colleagues was actually a much younger developer, and he told me that in order to build cloud-native applications, you need to build modern applications, you need to use microservices, containers, DevOps, and other technologies that I didn't know. And don't get me wrong, I like to learn in general, but at that time I felt overwhelmed and I had too little time to learn everything. Now, and I think that's why I came up with reasons why cloud native does not make sense. For example, I try to convince myself that cloud native is only useful for very few scenarios, that it's way too complicated and probably just another temporary hype. Now, when I was preparing this talk, I told my family that I want to share this story with you. And just a couple of days earlier, we had watched the movie The Croods, which is one of our favorite movies, and all of my children love it. And my family told me that you were like Grug in that situation. Now, for everyone who doesn't know the movie The Croods, Grug is the father of a family who lives in a cave in the Stone Age. And in order to protect his family, he teaches his children never not be afraid. In other words, be afraid. And he tells them that everything new is bad. Now, I have to say that my family was right. In that situation, I behaved like Grug. I considered the new microservices to be bad without really understanding them. Now, keep this story in mind. I will get back to it later, and I will tell you how it ended. But now, let's fast forward to today. It turned out that cloud native was not a temporary hype. In fact, the topic is more relevant than ever. And in the meantime, I've been able to work with microservices. In fact, Harald and we have developed an example application that shows how to get started with microservices. And that application we're going to use throughout this session for our demos. And we have open sourced this example so that every one of you can run these demos yourself on your notebooks after this talk. Okay, so let's get started with the definition of microservices. This is the definition from Wikipedia, and I think it's pretty good. Microservices are a software development technique that structures an application as a collection of loosely coupled services. In other words, you break down complex applications into smaller and simpler microservices. And this technique is really the core concept for cloud native. So what are cloud native applications? Not every application that you deploy to the cloud is cloud native. Let's take an example. When you use an existing application and you put it into a virtual machine and deploy the VM to the cloud, that doesn't make the application cloud native. Instead, cloud native applications are applications that really leverage the advantages of the cloud. For example, scalability. But there are other good reasons to write cloud native applications. And one is elasticity. That means that your applications remain responsive even when single microservices are not available. And similarly, you can continuously deliver new functionality because you can update the single microservices independently from each other. So, good news, there are many new options and possibilities for us as developers. But that also means that we as developers, we have to understand these options and new possibilities. We have to understand the advantages, disadvantages, and etc. And as illustrated on the slide, when there are multiple doors, we need to decide which door we want to open and go through. And also, new options often lead to new challenges. And here's an example. When you break down a complex application into microservices, for example, if you have a service A that wants to invoke a service B in a distributed environment, what happens when the service B is not available because the network is down? Okay, so after this quick introduction, let me now be more concrete and let me describe how exactly to build your first cloud-native applications and your first microservices. The first thing you need are images and containers, because that's how microservices are packaged and deployed. And here's the definition of a container image from docker.com. A container image is a lightweight, standalone package of software that includes everything needed to run an application, or in our context today, to run a microservice. And at runtime, these containers run isolated in their own sandboxes so that they don't interfere with each other. Let me get back to the story about Grug. Because as I said, Grug, he preferred to stay in the cave in the movie. But at some point in the movie, the cave was destroyed. And that meant that he and his family had to learn how to live outside of the cave. In other words, they were forced to learn something new. And that actually mapped to my situation a couple of years ago, because as a developer advocate, I was no longer able to ignore microservices. I had to learn them. And I think Grug has a good point here, because he now, after he left the cave, he wants to become a microservices developer. And he wants to know what containers are in a way that he understands it. So let me try to explain again what containers are, and let me give you a concrete example for how to define and how to build a container that runs a Java application. Easy enough so that even Grug, as a caveman, can understand it. So the big advantage, the key benefit of containers is the portability. And as you probably all agree, naming can sometimes be challenging for us as developers. But in this case, the name container is really good. Everything you need to run an application or a microservice, you put in one box. The operating system, the application server, the application itself, and all of its dependencies. And that really addresses a problem with classic architectures, where you typically deployed lots of applications on one big application server. And that led to huge management overheads, and it slowed down the updates. With containers, you put everything, again, in one box, and that means you can ship these containers easily to other environments and run your microservices in these other environments. And I think that's a brilliant concept. Okay, so now let's take a look at the code. It's very, very simple to get started. This is the Docker file here in the right column, and that's all you need to do, 3 lines of code. Now, I'm a big fan of open source. And that's why we've used here a stack that is fully based on open source components. Okay, number one, the virtual machine. As the virtual machine, we are using OpenJ9. OpenJ9 is the VM, the Java virtual machine from IBM, and we are using it in hundreds or thousands of offerings and services. In other words, it's enterprise proven. The other nice thing about OpenJ9 is that it requires 60% less memory than Hotspot. And the startup time is 40% faster than Hotspot. In other words, the JVM OpenJ9 is a great fit for container workloads. And the reason, by the way, is because it was originally designed to run on really small devices. The next component here in the stack is OpenJDK. I'm using an OpenJDK from Adopt OpenJDK. One advantage is that it's free. The other advantage is that you even get security updates, free security updates of a particular JDK, even after 6 months of the initial release. The next component is OpenLiberty. That's the application server I'm using here, and that's the open source version of WebSphere Liberty that comes with MicroProfile. And I'm going to describe and introduce MicroProfile a little later. So now, again, let's take a look at the Docker file. Only 3 lines of code. The first one says, extend an existing OpenLiberty image. Right? And this image comes with the exact stack that I just described. The only other things you need to do here is to add 2 more images onto the 2 more files onto the image. The first one is the server configuration, and the second one is the WAR file that contains the implementation of your microservice. So really simple to get started. Now, next, Harald will introduce Kubernetes to explain how to run these containers.
Okay, we just learned that a cloud-native application means to split your application into multiple microservices. So we have more than one service, more than one container. That means we need a tool to deploy those services into containers, to scale them, and to keep them alive. That's container orchestration. And one of the most widely used tools for container orchestration is Kubernetes. It's open source, it's the de facto standard, and it's used by basically all big public cloud providers, including IBM. It's also used to provide cloud capabilities in your own data center, maybe in the form of Red Hat OpenShift or IBM Cloud Private. So Greg has a point. If a container contains everything I need to run a microservice, why do I need Kubernetes? Well, in a microservices architecture, we have more than one service. Eventually, we have more than one instance of a service. So we need something to help keep this alive. And if we look at our example, you will understand that. This is our example application, or it's the front end of our example application. It's a typical web application running in a browser, written in Vue.js. It lists a collection of our blog articles, and for every article, it lists the title, the author's Twitter link, and a link to the author's blog. Very simple. And that's very simple, the architectural diagram. We have the web app in the browser that we just saw, and it sends REST requests to a web API running on Kubernetes, a web API service, which is a backend for front-end pattern. And the web API service retrieves the articles from an article service and the author details from an author service. So we already have 3 services that need to be deployed into containers and that need to be alive for our application to run. That's what Kubernetes does. Kubernetes also helps the web API service to talk to the articles and the author service without knowing any details, like on what node are these services running, what's their IP address. Kubernetes does service discovery for us. And here, on the right-hand side, you see some sample code from the web API service written in MicroProfile Java. And in the first highlight, you can see that for the URL, for the REST service, we only need the name of the service authors, plus of course the port number and the URI of the endpoint, but Kubernetes does the rest for us by name resolution. In the second highlight, you see that in order to make the REST call itself, we simply call a method from the microprofile REST client library. It's like any other method call in Java. It's type safe, and Niklas will talk about microprofile in a moment. So another important tool for microservices architectures and cloud-native applications is Istio. It is open source, like Kubernetes itself. Istio provides something called a service mesh, which is a transparent layer on top of your distributed application. Istio helps us run a microservices architecture, and it provides ways to control the data flow, to secure the data flow, and to monitor the services. It does so by using proxies. They are called Envoy with Istio, and the envoys handle the communication and the data flow between the services. This allows us to use a service mesh without adding additional code or libraries to our services, and it also helps us to implement polyglot microservices. It's language independent. So another good point from Greg, why do we suddenly need a service mesh? And I think that's easiest explained with another example, with a typical Istio example. Istio has many features, many cool features, but one of the really good ones is traffic management. We know dark launches, canary deployments, A/B testing. We introduce a new service and we want to test it on a limited set of our users. In our example, you can see that we now introduced a version 2 of our web API. They are very similar to each other. This is version 1. It displays 5 articles, and version 2 displays 10. No big deal. It's a simple example. If I could refresh the browser now, you could see occasionally version 1, occasionally version 2. So if we use Kubernetes alone, we would do a rolling release, which means we would deploy version 2 and Kubernetes would start version 2 and stop version 1. If something goes wrong, we roll back, Kubernetes stops version 2 and starts version 1. That's not a lot of testing. There are other ways, there are ramp deployments that can do something similar, but not as simple as Istio. With Istio, we deploy both our versions at the same time. We label them version 1, version 2, and then we create a virtual service with a rule. You can see it in the highlight, and the rule says we direct 80% of all requests to the get multiple endpoint through version 1 of the web API, and 20% go through version 2. And this is how it looks like. This is Kiali, this is the dashboard for Istio, and in the graph you can see that of all requests that go into the web API service, 80% go to version 1, 20% go to version 2. The graph is built dynamically, so we see all the other services that make up our microservices architecture, plus we see a lot of statistical information like requests per second, and do we have any errors.
Okay, cool. So the next technology.
No.
Okay, the next thing I want to talk about is microprofile. The two technologies that Harald just introduced, Kubernetes and Istio, are generic platforms that you can use to run all types of microservices, no matter how they have been implemented. However, for certain microservices functionality, that's not sufficient. The generic platforms cannot handle everything. In some cases, you need to implement business logic in your microservices. And that's exactly where frameworks, language-specific frameworks like microprofile come into play. And again, I think Greg has a good point here. He learned quite a bit already today. So let's keep it simple and let me give him and you a simple example that explains why and how you would use microprofile. The sample I want to use is resiliency. Again, this is our sample application with the 4 components. What I want to show next is how the web application and the web API service can remain responsive even when both the article service and the author service are not available. As I said, this needs to be done in the code, in the business logic. And this is the implementation of the web API service, specifically the implementation of the API that returns a list of articles. The snippet here at the bottom shows how to handle the case when the author's service is not available. Rather than not returning anything, the list of articles is returned, but simply without author information. The next snippet here shows how to handle the case when the article service is not available. In this case, an exception is thrown and a microprofile API functionality is used called @fallback, so a new Java annotation. And this fallback annotation kicks in when an exception is thrown. In other words, another fallback method is invoked. And in our case, that means that this fallback method simply returns the articles that were read the last time the article service was available. In other words, this information is simply cached. And here's how it looks in the UI. This is the fully working web application when all services are available. As soon as you shut down the author's service, the information about the authors, the links to the Twitter profiles and the blogs disappears. But at least you are still able to see the list of articles. And even when you delete or shut down the article service, you would see the same UI, the same list of articles, because again, this information has been cached.
So he already thinks like a developer. We have the situation, we no longer have a monolithic application, so we no longer have a single log file where to look into if we have problems. So with microservices architectures, we have more implications that we need to be aware of as developers. This leads us to observability. We are in a dynamic environment where objects come and go. For example, if you have a very active Kubernetes cluster, Kubernetes may stop a pod on one worker node and restart it on another worker node just to spread the load over the cluster. So as developers, to observe our application means we need to observe moving targets, which means we need different tools and new tools. We need distributed logging. We need distributed tracing because our requests pass through many different services. We need monitoring and metrics. So thinking about distributed logging, we have three services that run in 3 different pods, in 3 different containers that create 3 different logs. If something goes wrong, we don't want to look in 3 or more different places. We want to have a single place to look at, and that leads us to distributed logging. And one of the examples of distributed logging is LogDNA. That's the logging service we use on the IBM cloud. It integrates extremely well with Kubernetes because the LogDNA agents are deployed as a daemon set in Kubernetes itself. They run on every worker node. They collect everything that can be collected in the cluster and presents it in a single place. This is actually an interesting setup. Niklas said we try to run everything on Minikube. So this is a LogDNA service running in a cloud data center in Frankfurt, and it is connected to a Minikube running on my notebook in Stuttgart, which works as well. And in this example, in the headline, you see I filtered on 4 apps. These are the 4 apps that make up our sample application. And in the highlight, you see log information coming in from articles, from web API, and from authors. So let's create a problem. I killed the author service. I had simply deleted the author's deployment. And when we look into log DNA, into the dashboard, we immediately see there is a problem. We see that the web API is still able to talk with the article service, but it doesn't get a connection to authors. We also see no entry of the author service, so maybe it's down.
Okay. All of the samples, all of the demos from today are available as open source. You can find the link to the repo here in the lower right corner on the slide. We will also put we will also display a QR code on the last slide of this talk that points to the same repo. Harald and I, we've spent a lot of time to make the first time experience of this example as easily as possible. As I noticed the other day, we actually wrote more lines of code for scripts than actual Java code. For example, for every service, there's a script to deploy the service, to delete it, to see the logs, etc. We've documented how to run this example locally on Minikube. And even if you haven't set up Minikube yet, you should be able to do so and set up the complete sample application in less than an hour. So I think for everyone who wants to get started with microservices, this is a great starting place. And here's the architecture of the complete application. There are several other services and components, for example, to do authentication, authorization, observability, and persistence. If you want to find out more about those topics, again, go to our repo. There's a documentation section, and we have also written a series of 20 blog entries about it. The other thing I want to point out here is that the core components of this example are all available as open source. In other words, everything that you see here in the two left columns. The cloud services in the right column are not available as open source. However, they are only optional, plus you can easily exchange them with other implementations. For example, for the persistence of the article service, we use JPA, and that obviously allows you to switch easily to another SQL database.
Okay. I think we pointed out that we created the Cloud Native Starter around open source and made it run on Minikube so that everybody can start with it easy and simple. But we both work for IBM. IBM has a cloud, and on this cloud we have a managed Kubernetes service with a managed Istio. And if you like to try something that's even newer than that, there is even a managed Knative. So in the GitHub repository, we have all the information you need to run the example on the IBM cloud. And you can do that very easily because there is something called a light account for the cloud. You can register for it. It's free. It doesn't require a credit card. It doesn't expire. What's even more interesting, if you come to our booth downstairs in the expo area, you can get cloud vouchers like these with a code with which you can unlock additional features like access to a free Kubernetes cluster to test this for a year. So if you want, try it.
Okay, just to wrap it up really quickly. As you know, at the beginning of the movie The Croods, Grug taught his children never not be afraid, and he told them that everything new is bad. As I said, at some point in the movie, Grug and his family had to leave the cave, and they had to learn how to live and survive outside of the cave. But not only that, they also appreciated the advantages of being able to live outside. So at the end of the movie, Grug doesn't tell his children anymore, never not be afraid. Instead, he tells them the exact opposite, never be afraid and try out new things. I hope that in this talk we demonstrated that cloud native is no magic, it's not as complicated as some might think, and everyone can learn it. Thank you.
Thank you.
Thank you both. Much appreciated. Hopefully you guys learned from that and gained from it. We've got a short break now for literally a few minutes, and then we'll be going into our next session. So literally a few minutes, and then Rasmus Lerdoff will be on stage with us. Thank you. Okay, welcome back. So, next speaker. Lovely to see lots of you in here. He is known for having gotten the PHP project off the ground in 1995 and has contributed to a number of other open source projects over the years. He was an infrastructure architect at Yahoo for more than 7 years and has been at Etsy since 2012. You know, something I didn't know, I've never met anybody who was born here. He was born in Greenland. Anyone know anyone born in Greenland? No, so we now do. So here's one phrase to live by. Show me the code. Please. Welcome to the stage. Give him a hearty welcome, Rasmus Lerdoff.
Hello. My slides? Hello? No? So, they said it was working. They were wrong. Hold on. I have to turn on mirroring. Oops. Keep changes. Okay. Now we're good. All right, yes. Like Madeline said, I am from Greenland, actually an island off the coast of Greenland, to be even more remote, way, way up there, northern part of Greenland. This is me over 50 years ago, so it's not just 25 years of PHP, this is the full 50 you're getting. More me in Greenland. My whole family in Greenland on our dog sled. Our house. The view in the summertime. And me getting technical. This was a crazy place to live. But fast forward another 20-some years. My first computer, Timex Sinclair, had 1K of memory. Absolute craziness when you think about the devices we have today. The normal progression, Hayes modems. For half of you in the audience, you've probably never used a modem like this. I see a few older folks who definitely have. Sitting there staring at Z modem all day, waiting for all your downloads to download. This was the internet for me when I was many of your ages in the audience. In the 90s, we still didn't have the web. The closest we had was Gopher. And I worked a little bit with Gopher. It was basically hypertext or linked text documents with a text-based browser, mostly used in universities. But the whole world changed when Mosaic came out in 1993, which is when my 25-year journey began. As soon as I saw Mosaic, I knew the world was going to change, and change drastically. I started writing web applications. They look like this. CGI, scripts written in C, with HTML inside the C program. This was not a very nice way of solving the web problem. Most people moved on from C and started using CGI PM. This was a Perl module for writing CGI applications. I still didn't like it. This was simply writing HTML in another language now. I wanted my HTML to look like HTML. I wanted it to look more like that. I wanted to separate the business logic from the templating on the front end look and feel of my dynamic web applications. Behind the scenes, what I was trying to do, which turned out to be a complete failure, was to introduce a C API for the web. And I thought this was a great idea, because every time I started to build a new web application, I was writing all this boilerplate code. So I took all these things like parsing cookies, parsing posts, sending cookies, doing all the HTTP-related things, and also communicating with Apache, the web server at the time. All those things were the same in every project. So I abstracted that away, and I just gave a very, very simple stack-based C API for the web. So if you wanted to add another tag to your templating system, you could do it like this. So this was a cosine example. Pop the argument off the stack, do whatever your function does, in this case called the cosine function, and then pop the return value back onto the stack. And now suddenly you had this cos function that you could use in your PHP templates. And my whole thing was for people to write their business logic in a strictly typed, compiled language like C or C++, and then surface it within the templating system that I wrote for them. A very, very simple templating system. But this whole idea didn't work at all. Nobody wanted to write C code. Everybody just wanted to use the templating system that I had given them. And it drove me crazy for years. People would complain about things that they couldn't do in the templating system. For example, someone wrote me one time, why can't I call my function from within my function in PHP? Well, that's recursion. Why would you need recursion in a templating system? And they came up with some big complicated reason for why they needed recursion. I looked at my state machines, like, okay, I can implement that, fine. Now you have recursion in your templating system. I think it was 3 days later, I got another email saying, help, how do I stop it? Because there weren't any statically typed variables or anything like that. There was absolutely no way to end the recursion. But they didn't ask for that. They wanted recursion. I gave them recursion. Lots and lots of recursion. But the point was that PHP started its life as a templating system, as a very restricted, limited templating system, where the idea was that you were supposed to write your business logic and expose it via PHP, not write your business logic in PHP. And that just didn't work because nobody wanted to do that. The web was moving too fast. There weren't enough C developers in the world to meet the need. And everyone started writing their business logic in PHP itself. And PHP has received a lot of criticism over the years, most of it based on the fact that this is actually, it started life as a templating system. And it took us a while to change direction. It took me a while to change direction and to focus on the templating system itself as a language. I refused to call it a language for the first 5-7 years of its life. It wasn't, it was a templating system. What I worked a lot on, however, was the ecosystem around it. There's absolutely no point in having a very pretty programming language if it can't talk to anything. And if it doesn't cooperate and live within the whole ecosystem of things. And you need 4 things. You need an operating system, you need a web server, you need a language to write your logic in, and you need some kind of data store behind the scenes. And this is where LAMP came from. It wasn't an accident. We made sure that all the pieces fit well together. I spent a lot of time writing the Apache module for PHP, mod PHP, so that PHP and Apache were so intertwined you couldn't even tell them apart anymore. PHP sits inside Apache and is an integral part of Apache. On the database side, back then the database I was using was called Mini SQL. And this was before MySQL existed. And because I didn't have the money to buy Oracle, and I didn't need it for most of my web applications, I just needed a simple database. And Mini SQL was great for that. But it didn't have cursors. It had no way of restricting the amount of data you got back when you did a select star. So if you were unlucky and you hit a table with 100,000 rows, select star, you were waiting a long time for that result to come across the wire. And if you only needed the first 10, it kind of sucked. So that's where I added the limit clause to Mini SQL. And we still have the limit clause today. This limit clause has now sort of percolated up into other databases because it's just super useful. But coming up with the limit clause was part of building this web ecosystem where we live, where we write our business logic. Much more than just the language itself. The entire ecosystem has to work well. I also spent a lot of time trying to simplify things and trying to make PHP as accessible as I possibly could. I worked for IBM for a while, and I was actually on the WebSphere team. And if any of you have ever used WebSphere, man, that thing was complicated. I remember trying to write my first WebSphere application, and I asked for the documentation, expecting like maybe a small text file or something, but they came with this whole bookshelf, rolling bookshelf of books. Here's the documentation for WebSphere. And just getting a Hello World application up and running in WebSphere was really, really hard. And it shouldn't be. Hello World in PHP. Open up whatever text editor you want, type Hello World, save. What else could it possibly do than spit out Hello World? Right? It's the world's shortest Hello World program. And the text file just containing the 2 words Hello World is a perfectly valid PHP program. Because PHP is modal. When you don't pop into PHP mode, everything gets output. But it's a perfectly valid program. You don't have to do echo Hello World. You can just put Hello World in a text file. And that's part of this idea of making it accessible and scaling it down. It's amazingly powerful when the first thing you try, when you're trying some new technology, if it just works. And it's super, super motivating. You try something, it works, and it's like, whoa, that worked. What else can this thing do? This is fun, right? PHP is amazingly good at running crap code. And yeah, it sounds a little funny, but it is super important that it does something other than give you 3 pages of stack traces when you do something that isn't quite right. It should do something. It should do something useful. It shouldn't tell you over and over again, you're stupid, you're stupid, you're stupid, like most Java errors do. You just pages and pages and pages of crap that doesn't mean anything to the person who made the mistake. And if you think about the web as it is today and how it has grown over the years, the fact that there was an accessible tool where anybody with a good idea could put their idea online has made the web a much, much better place. If only geeks like me were allowed to program the web would suck. Because I'm pretty boring. And most developers are pretty boring people. We like bits and bytes. We like crazy things that normal people really find not interesting and annoying most of the time. So the fact that it's accessible and it runs crap code really well is super, super important. So over the years, we focused a lot on performance, especially lately. Robustness has always been a thing as well. It's fine that it's easy to use, but if it crashes all the time, it's not useful either. I always avoided going multi-threaded. One request, one process, no shared state. That also means it scales infinitely because it's this perfect sandbox where everything is created and torn down in one request. There's no server-side variables or anything like that that you need to maintain state, so you can just throw more servers at a problem, and it just works well. So this perfect sandbox model in 2019 language we call serverless. This was serverless before we have ever thought of the word serverless. Get lots of questions over the years about lots of stuff. Naming inconsistencies in PHP. PHP is perfectly consistent, just not in the way you expect. Most people, when they look at consistency in a language, they look horizontally across the language. Do the Oracle functions look like the MySQL functions? No. PHP is vertically consistent. If you know the Oracle API called OCI 8, those Oracle functions in PHP are going to be very, very, very familiar to you. PHP is a very thin wrapper on top of hundreds of underlying libraries, and it mimics those underlying API libraries that they wrap. So vertically, every single function in PHP is perfectly consistent with the underlying library function that they implement. It looks inconsistent horizontally because the libraries are not consistent. If I had taken the time to make it horizontally consistent, I'd still be working on it. There were just too many libraries to implement, and there were also many people doing it. It wasn't me. Lots of people doing it, and coordinating everyone to force them into the same API would have slowed us down way too much. Oops. People always complain about needle haystack inconsistencies. Do you realize that every string function in PHP is haystack needle, and every array function is needle haystack? It's not completely random. It is consistent within the string functions and within the array functions. All right. So, for the past 10 years or so, a benchmark against WordPress 4.9.8, we have gotten quite a bit faster every single version, with a huge jump from PHP 5 to PHP 7. PHP today, if you use PHP 7.3 or the upcoming 7.4, is a really, really, really fast scripting language. Faster than any other scripting language out there. And we spent a long time in the past 5 years getting to that. In the PHP 5 days, we weren't that fast. We were in line with existing scripting languages at that point. But in the last 5 years, it's really, really changed. Also, the memory usage. In 2009, PHP 5.3 on WordPress would need about 140 megabytes to serve up the WordPress front page. Today, we need 15 megabytes. So if there's anyone in the audience still running any version of PHP 5, you're kind of lucky, because you have this massive performance and memory boost sitting there waiting for you. And the upgrade is really easy. And if running on AWS or somewhere, you can turn off 2/3 of your instances once you upgrade, which the people who pay the bill will be quite happy for. And my son will be quite happy for the less carbon dioxide that you'll be spitting out into the atmosphere by running more efficient code. Also, PHP 5 is completely unsupported these days. If you find a security problem in PHP 5, if you find any kind of bug, I'm not going to fix it. You're completely on your own. So please upgrade. If you find a problem in PHP 7.2 or 7.3, we'll fix it for you. For free. So, but there are no bugs, only features in PHP. So, PHP 7.4, this is the new version coming out this year. There are a few new things in it. Type properties. So, class properties can now have a type. It's a slight performance hit, but we're hoping Dmitry, our superstar Russian hacker in St. Petersburg, will find other ways of speeding things up so that you won't notice the slight performance impact that this has. Arrow functions. This is a short form for closures. So these two are identical. You can see we use auto capture here from the immediate outside scope. Serialization of objects has been a nuisance in PHP for a very long time. It's been semi-broken as well. The serialized and unserialized magic functions coming in 7.4 are one step towards addressing that and making it a little bit easier to serialize and unserialize objects in PHP. We'll see how that goes. But it should address most of the issues that people have currently with object serialization. There's a new operator, question mark equals. It's the same as this line here. It's just an assignment version of the null coalescing operator. We're also introducing weak references. Weak references were available as a PECL extension up until now, but it was kind of broken and old. Now we have full weak references in PHP. And the weak reference is a reference that doesn't count towards the reference counting. So PHP is a reference counted language. When you create an object, for example, and then you say A equals new thing, and then you say $B equals A. Now you have two references to this object, $A and $B. When both $A and $B go out of scope, the reference count drops to 0 and the object is destroyed. Now, in some systems, you might have some kind of cache, like an ORM might have an object cache, for example. So even when you eliminate $A and $B, the cache reference will keep that object alive, which isn't necessarily what you want. Once all references to an object has gone away, you might actually want to get rid of the object. So with a weak reference, your cache system could say, I want a weak reference to this object, which means that it won't count. Once the real references have gone away, the object will be deleted, even though there's a cache reference to it, because that reference is weak. It doesn't count. So for cache systems, weak references are kind of interesting. Another super cool new feature is something we call opcache preloading. It means that at server startup, you can load PHP code. And those classes or those functions defined in the preloaded code will appear as if it's part of native PHP. So you could, for example, take your entire framework, like Laravel, and preload it. And by preloading, it means that the entire Laravel framework is available to every request. And performance-wise, it'll be a little bit quicker than not preloading it and loading it per request. Now, the opcache already stores Laravel opcached in shared memory. So the performance benefit isn't huge. It's small. It's 5 to 10%, which still is important. However, preloading is really important for this next bit. FFI. FFI is the foreign function interface. And you've seen that in other languages. Java has it, and other scripting languages have it as well. And we've had it for a while as a hacky extension, but now in PHP 7.4, it's coming in as a full language feature. And it's a little scary because it can really screw up the server. This allows you to write C code that gets compiled right from your HTML or right from your PHP application. So a very simple example, you can bring in libc and basically call printf in libc directly from your PHP script, which is okay, but it's not super interesting. I did another example. I went on GitHub and I found this GIF-enc library. This is a GIF encoding library for doing animated GIFs. And here I create an unsigned int 8 type, an array of unsigned int 8s because the library needed that. And I do FFI load the header file. This FFI load creates this FFI object that basically compiles the C code and links in the library. This step takes a little while. This is why for FFI, you need the preloading. So by preloading this FFI script, it means you're basically on Apache or Nginx or FPM startup, you're compiling all your FFIs and making it part of PHP. In the not too distant future, I can see a lot of simple PHP extensions moving completely out of C and into PHP FFI so that you can compose or install MySQL extension, for example. Well, the MySQL extension might be slightly too complex, but many simple wrapper extensions will be simple composer PHP scripts that will run just as fast as they do today in pure C, because they will still be pure C, but all the data management in the extension will be written in PHP. So it'll also be more accessible to more people to work on this extension code. So the combination of opcat preloading and FFI is going to change the PHP landscape, I think, in the next 5 years. But we'll see. We'll see if I'm right. So for this particular example, all I had to do in the header file was add these 2 lines. You give it a scope, basically you give it a name, and you tell it what's the name of the shared library that this header file applies to. And you feed that to FFI load, and that's all you need. Now you have an FFI law object where you can call methods that are directly in this shared library. And the output is that. Not super exciting, but this part is kind of exciting to me. Also because if you think back to the beginning of the PHP project, what was I trying to do? I was trying to get people to write C code, right? Full circle. All right. These 25 years of PHP has also included me having a kid. This is me some 17 years ago with Carl, my son. He used to come to conferences with me. This was in Karlsruhe many years ago. He loved running around the exhibit hall, and his great skill was finding the off switch for anything. Any server he could find, anything he could find, he would go in, he would turn it off. And he would systematically circle the entire exhibit hall and turn everything off. And people really didn't like that, but they knew it was my son, and he had his PHP shirt on with his cute blonde hair. They couldn't really do anything. But he would do the lap again and again. Yeah. Today he's playing video games in his Tesla. It's a very, very different life now. It's amazing how fast they grow up. Some other highlights for the 25 years. I used to go to Australia every year for the Linux conference down there. This is Tridge arguing with Linus over some point. Tridge wrote rsync, Samba, a bunch of things. Linus is Linus, obviously, right? This was another fun moment in my 25 years. This was me going to some conference in India. I don't own a suit like that. So, the organizers in India figured out this is a serious conference with serious speakers. This guy sent us a picture of him in a t-shirt, what the hell? So they photoshopped a suit on top of my t-shirt. And the first thing I see when I arrive in this city are these huge signboards everywhere of me in a suit looking very uncomfortable. Another highlight. Anyone recognize the person sitting here? A hint, this was in Sri Lanka in 2003, I think, or 2004. Very famous science fiction author who lived in Sri Lanka since the 50s. Arthur C. Clarke. This was probably the highlight for me, because I'm a big Arthur C. Clarke fan. Space Odyssey, 2001, etc. Teaching Arthur C. Clarke PHP was awesome. He was sitting in the front row, paying attention, asking intelligent questions. Really, really cool. But something even cooler came out of this Sri Lanka conference. One of the reasons that I'm still doing this today, 25 years later, is because of projects like this. This project is called Sahana. This is a couple of kids in Sri Lanka right after the big tsunami that had wiped out some coastal cities in their country. They wanted to do something. And I talked to them, and they were distraught because they had family members who had died. And for reasons that had nothing to do with the tsunami, really, it was all logistics and foreign aid not getting to the people who needed the aid. And we chatted a bit about it, and they had this idea of fixing this problem, of writing basically a disaster relief management system in a box that could be quickly deployed in case of a disaster anywhere in the world. And they built it. And it's now been used in over 50 disasters all over the world. And it has things like a people finder, and there's a mobile app for it now as well. So when a relief worker finds a person, or when they rescue someone, they ask them their name, they type in the app, the name of the person, and where they put them, like shelter number 3. And then people looking for their grandmother can type in their grandmother's name and very quickly see, oh, she's been found, she's in shelter number 3. Same kind of things for foreign aid that gets delivered to the airport. Someone is there with the mobile app saying, okay, we have blankets, or we have clean water in warehouse 4, right? And when someone needs clean water, they type it in, going, whoa, where can we find it? Okay, we know it's in the warehouse 4, right? Very, very, very simple stuff. But many, many countries in the world don't have a system like that that's easily available when something terrible happens. And this project has received a lot of recognition over the years for what it has done for the world, basically. And I love this quote from the Secretary of National Defense of the Philippines. Like, no innovation matters more than that which saves lives. And it also reminds us a little bit of why we're doing this stuff. This stuff is just a tool. Development is a tool to solve real problems in the world. It doesn't matter that much. PHP doesn't matter that much. The tool doesn't matter. It's what we solve. It's what we do with the tool. PHP is just a hammer. It's irrelevant. All the tools are hammers. In and of themselves, they're irrelevant. What we do with them is super, super important. So my plea to people is, please work on things that matter. Perhaps only to you, that's fine. If you don't work on things that matter, you're going to burn out. You're not going to be programming for the next 25 years of your life if the thing you're working on is completely insignificant to the world. At some point, you're going to wake up and say, what the hell am I doing? So, I see 3 types of people in our development world. I see the dreamers. I get probably once a month, some Silicon Valley person has a great idea, and he said, all I need is a technical co-founder, and we can rule the world. What he means is he needs someone to do all the work, right? He has some harebrained idea that may not work at all because he has no technical basis at all. Dreams like that are kind of useless, right? I would love a plane that's 10 times faster so it doesn't take me 11 hours to fly from California to Germany. But I want to survive the trip. So the person who comes up with this plane that's 10 times faster better know a little bit about physics, right? You need a basis in reality for your dreams. On the other edge of the spectrum, we have the coder who just loves to code. Doesn't matter what. Couldn't care less what they're coding as long as it's cool code and the tool is cool. And they have 37,000 lines in their vimrc file for all the weird macros they have for doing cool things with Vim. And that's what's important to them, and that's what they talk to each other about. They talk to their friends about their Vim macros or Emacs macros, whatever. I'll never understand that part of geekdom. What I talk to my friends about are the things I've solved, are the problems I'm working on. They don't care which editor I used. Certainly the end users of your applications don't give a crap which editor you used and which language you used to solve the problem. As long as when they click buy in the application and their socks arrive the next day, they're happy. And what I talk to my friends about are projects like I work for Etsy, which is basically a shopping cart, but it's for artists and makers to sell their things. And what I talk to my friends about is going to Mexico and helping bring Etsy to rural Mexico so that the people making pots and selling them to a middleman for $1 a pot, and that middleman then sells that pot at the Mexico City airport for $400. I tell my friends, I helped this potter cut out the middleman and sell directly to rich Germans for $300 a pot versus $1 a pot this artist got before. Changed their entire life and changed the economy of an entire village. To me, that's what matters, right? Make an impact. Yes, you're good with your tool. It's great that you have fun with your tool, but never, ever, ever lose sight of why we're doing this. And yes, I'm squarely here. So, if it wasn't obvious, I sort of advocate people try to drift to the middle, have a bit of both. Dream a bit. If you're a hardcore coder, get out in the world, see the world a little bit. Leave your Vim macros for at least 30 minutes a day and look at the world. And if you're a hardcore dreamer, learn to code. It's really, really easy to learn to be a crappy programmer. There are so many resources everywhere that will teach you terrible things that will give you just enough to at least know what's possible, to know what's easy and what's hard and what's impossible. So that when you do go and talk to your crazy whys, you can speak the same language. All right, I have a little bit of time for questions. So.
To go. Right.
Do we have any?
Oh, always, always.
Always.
Okay, so let's move over a little. So your center stage. Right, so first question. If you had a chance to redesign PHP from scratch, would you do it differently?
I think any developer who says no is lying. Every single piece of code you've ever written, if you go back, especially if it lives beyond the weekend, there are things that you say, oh man, I should have done this differently. So yes, of course there are things I would have done differently. PHP at the very beginning started as a hack just for me. My target audience was one person. If I had known that 25 years later I'd be standing here talking to a hall full of people about this little hack, of course I would have done some things differently. But at the same time, what I would have done differently is probably not even done it at all. Because who starts a 25-year project knowingly? Nobody. A 25-year unpaid project, here you go, start. Yeah, let's skip that, right? So, realistically, no. The only way PHP would have happened was the way it did.
Thank you. So if you had a chance to, so that question's gone. So what's your favorite language? Not counting PHP. And
Awk.
why do you like it?
I like awk. Awk is very simple, straightforward, descriptive. If you don't know awk, learn it. Man awk on your Linux command line, AWK. Awesome.
Okay, so what happened to PHP 6.0?
PHP 6. We were all keen on Unicode for a while, and it complicated things. We took too big of a step trying to make PHP completely Unicode throughout. And it got too complicated, and too many of our contributors looked at it and said, I don't understand it. I'll stick to PHP 5. And more contributors basically dropped off the scene as PHP 6 grew. And it wasn't sustainable. An open source project without contributors is dead. So we basically threw it away and said, okay, we picked a few pieces out of it, but we started over, went back to PHP 5, took the few good ideas from the PHP 6 tree, backported it to PHP 5, and that became PHP 7, just because we went down the wrong path with the Unicode implementation.
Okay, so which do you find closer to your ideals, Symfony or Laravel?
See, people always ask me about frameworks. If you think about it, PHP is not written in PHP. I'm really not a very good PHP developer. I spend my life in C and in GDB and in Valgrind debugging stuff at the C level. I have literally never written a Laravel application or a Symfony application. I've debugged them from a very low level, but I've never actually written a Laravel application. So when people ask me which framework do I like the frameworks. They're okay. I don't know. I haven't used them. I'm sorry. I'm the wrong person to ask about sort of PHP frameworks because that's not the level I work at. I am at the C level, at the debugging level, fixing things when a framework developer tells me, I tried this and we have a seg fault. I'm like, oh, interesting. Right? I love seg faults because they're very discrete and they're very sort of, there's a nice backtrace and you can figure out what's going on. That's the level at which I debug frameworks, is sort of from the seg fault back up. So I couldn't answer that question.
Okay. Rasmus Ledov, thank you so much for sharing with our audience. Please give him a warm round of applause. Rasmus Ledov, thank you. Okay. So, our next session is coming up shortly. We're just going to get everything set up. Hopefully you'll stay with us. If you're moving on, then have a great time wherever you're going. See you in a moment. Right, let's get moving. So our next speaker is Max Feldman. I don't normally say the name first, but he's a member of the product security team at Slack. Who uses Slack? I do. I think it's fabulous. He's been running and expanding the Slack Bug Bounty program, as well as launching the yearly security training, Capture the Flag. Last year, he literally went around the world speaking, going from San Francisco, all east, all the way until he returned back to San Francisco. Here's one phrase to live by: break stuff. So, speaking about bulletproof shoes, please welcome to the stage Max Feldman.
Hello, good morning. Welcome to our talk. So yeah, I saw a lot of hands up for people who use Slack. We're going to talk about some methods that Slack uses to keep Slack developers safe and to safeguard people and prevent them from shooting themselves in the foot. So hence the talk title, Bulletproof Shoes. So I'm Max Feldman. I work on the product security team at Slack. I joined 3 years ago yesterday, so 3-year anniversary yesterday. Before that, I worked at Salesforce on the product security team there. At Slack, I run our bug bounty program. I work on feature reviews there, making sure that we're shipping secure code and secure features. And I also do some training initiatives. I join our DevRel tours. We have a booth here. And I help with some of our platform security measures as well. So today we're going to talk about our token nuker. So I'm going to go over the problem itself. I'm going to go over the solution that we've built, some of the future work we'll be working on, some lessons learned, and time allowing, we might have a little time for Q&A. If not, Slack has a booth here, and I'll be around the conference. So Slack. A lot of you use Slack. What is Slack? It's a hub for collaborating. So one of the big features of Slack is bringing workflows together. So integrating with other applications, it becomes kind of a hub, a central point where you can use other apps, other integrations. You can build your own tools. You can build custom integrations. You can use things like Salesforce, Google Drive, Dropbox, Box, etc. So what is a Slack app? It's a lot of different things. It could be as simple as a webhook that's posting weather information. It could be something silly. We have a lunch train app. So if you want to go get lunch with your coworkers, you can use a / command to see who else wants to get lunch. We have a custom integration out in San Francisco of which food trucks are near the office. But we also have more powerful things. We have code reviews. We run our secure development lifecycle through Slack as well. I'll talk about the token nuker itself and how it's posting into Slack. But quick question, who has used a Slack app before? Yeah, so a lot of people, you have probably seen many of them. And so where do these Slack apps come from? So we have over 200,000 developers on the Slack platform. And that's not apps, that's active developers. That's individuals who are creating apps. They may or may not be on our app directory for public use. So it may be a custom integration for your own company. You may be running your, like doing chat ops or something like that. You may be pushing code, doing code reviews. You may be approving expense reports, etc. That could be custom. Or it could be something on our app directory. So we have over 1,500 apps in the app directory, and those are public, available to install. They're vetted for quality. We perform security assessments of these. And they're there to save you time and bring things together. So if you go on our app directory, you can see a lot of the apps that are there. And as many of you raised your hands, you've used them before. So brief architectural overview of a Slack app. So we have the Slack client. We have a Slack server. And then we have an app server. So this is the high-level overview of what makes a Slack app. And so apps need tokens. So we'll talk a little bit about webhooks. But in general, a Slack app will use the OAuth 2.0 API in order to get a token, and you'll have a user authorize an app, and they'll say, OK, yes, I grant these permissions, and then your app will get a token, and it can use that to communicate back and forth with Slack. So it can post information into Slack. It can access resources. These can have different scopes, and we'll go over some of those shortly. So like I said, when you're going through the app approval process, you click approve. You can see at the very bottom is where the kind of scarier, maybe more powerful things are. And at the top will be other permissions that the app is requesting. So you can deny them or approve them. And we have a couple different kinds of tokens. So who has built a Slack app before? Or a custom integration, or worked with the Slack API? Cool, so handful of people. We have user tokens, and so these are prefixed with XOXP. These allow you to work directly on behalf of a user, so a user grants some permissions, some OAuth scopes, and then this token has those permissions. We also have bot user tokens, which are prefixed with XOXB, and these allow a bot, which is kind of a powerful pseudo-type user, not pseudo as in with an S, but with a PS. So it's kind of a user, but it's not like an all-powerful one. But it does have some additional permissions. So those are two pretty common tokens. So that brings us to the problem. Who has ever accidentally leaked a token on GitHub or Pastebin? And you don't have to raise your hand if you don't want to. That's OK. But it happens. We have people doing tests. We have users who are trying to quickly get something together, and maybe you put a credential or a token in your dot file and you upload that for people's convenience. Or you're really proud of your bash RC and you forgot that it's full of your AWS credentials or something, and you put it on GitHub and then realize, oh no, that's publicly there. So that can happen with Slack tokens as well. Maybe you've built a Slack app, you shared it, and your token is in that repo. So it sucks when you lose your keys. So if we do a quick search on GitHub, and I'm going to note that this is old. This is no longer the case, and I'm also going to explain why it's OK, because we've nuked all of these. But you can see here, if you search for just XOXP, you get about 27,000 results. And a unique aspect of this is there aren't many other things on GitHub called XOXP or XOXB, so it's kind of like high signal-to-noise ratio. But so here's an example of the top match. So someone doing a test email to check API functionality, and they put their token in that. So if you go on GitHub and you search for these things, people have done this before. There are accidental leaks of Slack tokens. And so if we do a little bit deeper dive into some of the token scopes. If you've used Slack apps, you know that they are very powerful. They can do a lot of things. So maybe they can write to a channel. Maybe they can read all of the chats in your channel. Maybe they can get history, user information. So we have more documentation on the specific scopes, but they're very powerful. So if you lose a token, you might be thinking, oh, well, who cares if some attacker can steal my token and look at my memes or look at my GIFs, et cetera. Not all Slack users are just using it for memes. There are companies, corporations, people who are using it with sensitive data. Maybe you've discussed something like corporate secrets. Maybe you've shared credentials within Slack, which we advise you not to do, but maybe you have. And so if you have an app token that's been leaked, and someone grabs that, and someone hits the Slack API and says, hey, I just want all of these channels, there's a lot of information in there that can be taken. You can also post to channels. You could potentially impersonate users, or if you steal a bot token, maybe you're the new Jenkins bot, and you say, like, hey, here's some great code. Please put this in your repo and put remote code execution in your app. So we don't want this outcome. Another potential, well, there are a lot of powerful scopes. The admin scope can give an app the ability to administer your workspace. So it can add users, change users, et cetera, lock people out. It could completely, if in the wrong hands, these can be disastrous for your organization. So it can read audit logs, things like that, security sensitive information. And this is with the user token. The legacy token, it doesn't mean this is an API, but there's a type of Slack token called the legacy token. And so, yeah, that information in your Slack workspace can be extremely not good to lose to an attacker. So you could have your credentials, which, like I said, we advise against. You could have links to company-sensitive information. You could have files uploaded. You could have pay stubs. You could have social security numbers. Maybe your HR department handles all of your hiring, firing, etc., and it has messages in one channel of like, oh, this person was fired for this reason, etc., important files. You have a lot of sensitive information in there, and the larger the organization, the more data there is. And so people make mistakes. This is not necessarily super factual, but I mean, it's a little more qualitative than quantitative, but we can kind of see over time how the search for get remove history became more common. And I think it's fair to say that this becomes more common of a problem. The ease of coding, the ease of deploying things and putting things online has grown. More people can develop apps than ever before. There are a lot of different platforms. There are a lot of different ways to build something new, and it's exciting, and people do it, and then they don't realize that they accidentally published a token, and so they frantically Google, how do I remove this? And maybe you don't realize that it's also in the history, so even if you delete the file, it's still there somewhere, and you have to really thoroughly purge your Git repo if you're going to make sure that that token can't be found. But you also might not realize that by the time you've actually done that, someone else has already found your token and taken it off of GitHub, because there are malicious people on the internet. They exist, and they are running scanners of GitHub searching for Slack tokens. They're searching for AWS credentials. They're searching for passwords, etc. And by the time you delete it, it's already been taken by someone. So what we want to do is prevent developers from shooting themselves in the foot. So hence, Bulletproof Shoes, the title of this talk. We don't want the accidental leak of a credential to be catastrophic, to be org ruining, to be a nightmare, and everyone staying up all night rotating tokens and figuring out what's going on. And so that's why we built the Token Nuker. So I showed that if you search on GitHub, you can find tokens. And so what we built is something that does that. It searches, it finds tokens, and then we nuke them. So we revoke those tokens and make sure that they can't be abused. So an attacker who is, or a malicious individual or organization who's looking around for these tokens can't actually use them, because by the time they found them, we have already found them and invalidated them. So we want to automate all the things. We wanted to build a solution that is both lightweight and also fast, because it's kind of a race against time when you're worried about the threat of losing your tokens, so we needed to be quick. And so we built the Token Nuker. So the Token Nuker, at a high level, it's a little app, and it searches GitHub for tokens, and then it hits the Slack web app, and then it revokes those tokens. So there's a bit more complexity to this. We're using GitHub's. So this is how it started also. I'll talk a bit about the evolution. But we wanted something that we could throw together quickly and just have running and working. So we search GitHub for Slack tokens. Then we pull them into a database, and we have a note of what token it was and also what file. And so our database is for caching. We hash the file and token, so if we find it again, or if our search messed up and we have duplicates, we're only trying to revoke something once. And then we have a Slack web app endpoint where we revoke a token. And we have a shared secret between the two services, so you can't be some random person on the internet hitting Slack tokens, revoking them for other users, and causing kind of a mini denial of service for them. So we're caching this so that we can save time, and we're searching as quickly as we can and deleting as quickly as we can. And then once we have found something, once we've found a token that is actually valid, we post into a Slack channel. So we're actually using a webhook, which I mentioned a little earlier in our security tokens burn channel. And it says, hey, found this token at this repo, contacted this email. And so we have a big old channel full of this that keeps growing. Very heavy on the fire emojis. It probably is the largest source of fire emojis in the Slack organization, but it is constantly posting there. So this also provides like a searchable record. So if we need to look into things later, we have a nice little Slack channel that we can do it instead of just querying the database. So a couple of the challenges of this. Primarily customer engagement. So let's say we did this in the naive way. We find a token, we just revoke it. Then all of a sudden, someone says, hey, my app broke, or hey, this token's invalid. Or maybe many people start saying that. they start reaching out to customer experience and saying like, hey, your APIs are all broken, my app doesn't work. And then our customer experience folks have no idea that the security team is doing this. And then they say, well, we don't know why your token's invalid. Let's try again. Then they publish it again, and then their app breaks, and people start to get frustrated and bang their heads against a wall thinking, why can't I use Slack? This should be easier. So the customer engagement part is not crazy technical, but it requires some wordsmithing. It requires empathetic communication. And so we have to be detailed and say, what happened? What steps have we taken? And we use that channel to coordinate with our own CE organizations so that if a customer reaches out, if a user reaches out and says, hey, I just got this email and I'm a little worried, our folks can look at the channel and say, oh, we found your token on GitHub. We found it somewhere on the internet, and so we revoked it. You don't have to worry. You might want to check your access logs, but we're I'll show you shortly the modern version of the app, and I think we're about as fast as we could be for deleting tokens. Another concern, rate limiting. So if we're scraping GitHub too fast or if we're hitting our own API too fast, we have rate limiting on all ends, so we can't just nuke, 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 nuke. So sometimes we have to sleep a little bit. This is also good because if someone were to try and do a denial of service attack of this service by uploading like a big file with, I don't know, 1 million fake tokens, we do hit rate limiting. We don't get taken down. We can still have regular functionality and continue deleting and revoking the actual tokens that we need to be concerned with. Concern internally is maybe you introduce a new type of token, so we have changes in the platform over time, and so we coordinate with our API team, our platform team, to make sure that we're keeping all of those in mind. And like I said, you can't just say, hey, you revoked your token. You can't say nothing, because that will be annoying. You can't just say, hey, we revoked your token, because that doesn't give any useful information or anything actionable. So we provide clear reasoning. We say what happened. We want to give people pointers so that they don't do it again, so that they're aware of the issue and that they're aware of what problems could have happened. And we prepare our CE folks on what's coming. So I'm not going to read this whole email notification. We send out a long email to the owner of the token and the owner of the organization, and we say, hey, here's what happened. We have some helpful information for you. Please reach out if you have more questions. And that brings me to the evolution, so where we are today. So when we first spun it up, we were looking for a quick solution. We just spun up a server in the Slack infrastructure, and it wasn't really like we had to manually update stuff. We were just working as quickly as we could, but we've reached a point now where we're like, within legit infrastructure, automatically updating, it's more resilient, it's easier to provision and easier to get people onboarded as we expand functionality. We added a new token that we have, and one thing that I think is super exciting is GitHub has a beta feature for this exact functionality. So they have a token or credential alert process, and we are one of those tokens. So GitHub will search both public repos, and if a private repo becomes public, they will search for regular expressions that we've provided, and then they will send a message over to Slack saying, hey, we found this token. So currently beta, it works with AWS, a couple other credentials as well, and then GitHub sends this notification to Slack. And what this looks like is basically the same architecture, except now our token nuker server is also receiving inputs from GitHub. And those are signed, so we prevent someone pretending to be GitHub and saying like, hey, look, I found all these tokens. Not that, I mean, if you already had someone's tokens, it would be kind of annoying or a waste of time to send them to Slack to invalidate, because you might as well just do bad things with them. But we do sign them. So we receive those events. And I'm going to show a very cool graph in a little bit about how that has changed how well our search does compared to how well GitHub notifications are doing. So I talked a bit about webhooks. Incoming webhooks are the simplest and most powerful way to post a message to a channel. So really easy. You can do a post request. You can do just curl and say, hey, send this in. Powerful, simple, straightforward. But what could go wrong here? So with tokens, you can lose a lot of information. They're very, very powerful. With a webhook, it's more the content that you can inject. So you could impersonate an app. You could impersonate a user. You can try for phishing and social engineering, spam, things like that. But not quite as bad as tokens, but still not something that we want lying around. So if we do a quick search on GitHub for hooks.com hooks.slack.com/services, we see 52,000 results. This looks a little worse than it is. We've actually done a deeper dive, and so at first glance, this is pretty bad. But there are a lot of instances where this is just documentation, or they're not valid webhooks, or they're kind of filler webhooks. So the number of valid webhooks is much lower. But we might as well nuke them. We have a token nuker. It's built for nuking things. It's built for revoking things. Let's throw some webhooks in there. So this is something we're working on right now, currently in beta. We had to make some tweaks. So we already had existing functionality in the app for revoking and rotating tokens. We do have that for webhooks as well, but we had to plug them in a little bit more. So we're working on that, and we're working on the communications. So now I'm going to talk a little bit about the feedback we've received and the lessons we've learned through this process. So here's our history of nuke tokens. So we can see this is monthly, so it's 400-ish tokens per month that we nuked. When we first launched it, there's a big spike because we went from 0 to all tokens that we could find on GitHub. That is not in this picture, so there's like one day where it's just like, a bunch of tokens nuked. But here's a more steady flow. We had like a little spike towards the end of 2018, people getting ready for the holidays by publishing tokens on GitHub. And so we see here, though, this is split up over how we find those tokens. So we have two means of fetching tokens. We have the regular search, which is how we started, and we have the information that GitHub gives us. And the great thing about that is you see, like, once we launched that, it just became the main source of those tokens. And if a token has already been invalidated, we don't nuke it. So these data points are only tokens that were valid that we nuked. And that means GitHub is faster. That means we receive a notification from GitHub and we nuke that token. And by the time we search it and find it, it's already been invalidated because we did that. So we're working faster in almost every case with GitHub. There are a couple little blips there, but the vast majority of the tokens we're nuking now are coming courtesy of that GitHub beta feature. And then this is for more current information. Now the vast majority of our tokens are found by GitHub as opposed to search. So the first source of a token is GitHub and their beta feature as opposed to the search that we're performing. Another interesting data point is the number of tokens we're finding that are actually valid. So this is just tokens, not webhooks, but about 80% of the tokens we see are actually valid. So any token that matches the regular expression, we test and we try and invalidate. And if it's already invalid, we just make a note like, hey, this is invalid. So on the first attempt at that, 80% of those tokens are valid. So this is a legitimate concern. It is something that we want our users to be looking out for, but it's also something we want to be protecting them from. Another interesting metric, we grouped by team. So you can see at the very top, there is one team that had 19 total different tokens revoked. We didn't look further into that. It could just be a test team. It could be a team that's using bad test practices and putting their test tokens on GitHub. For the most part, though, we see a very long tail of 1. So most teams only have it happen once. And that's, 0 times is great, and 1 time is the next best level of greatness. It means you don't repeat your mistake. So if this happens to a team once, in general, they're not coming back and doing it again. So sometimes maybe it was a fluke. Sometimes we have teams that have actually benefited from our messaging and from us informing them. So one of our customer quotes is, just wanted to thank you. It's a nice service. I like it. That's great to get good feedback on a service of ours that's deleting a token of theirs and possibly breaking an integration. That's great feedback. In general, we've found that with our communication, people are able to respond to it and not be freaked out, not be too worried, and move on with their lives and follow good development practices. Franz Rosen from Detectify, he's a security researcher. He first started talking with this about us back in 2016. So that was a big impetus for this project. We kind of knew it was an issue. There's just general knowledge that people are leaking tokens, that people on Slack are leaking tokens, but Franz Rosen really put it into perspective for us, like the scope of the problems and the scope of the issues, and so we coordinated with him. We've also been talking with him about webhooks. Webhooks are a teeny bit trickier, and they're less dangerous than tokens, but we're working on this, and we'll be doing that soon. One other note is we're working on translating these messages. So we had an interesting little incident recently where we sent the communication out, and it was a Japanese customer, and they reached out to customer support saying, like, and this exchange was in Japanese, and they were saying, what does this mean? We don't understand this. Slack supports multiple languages, so our emails have to support multiple languages too. We're working on that translation, so not a super technical thing, but it makes it more accessible to everyone. So right now the emails are just in English, but if English is not your native language and you're reading about this, it may not be super helpful. So working on that. We do have a couple features that also can protect against this. We have IP whitelisting, so you can configure your app so that it is only allowed to communicate from certain IPs. Admin approved apps, so you can make it so that only certain apps are able to be approved by your administrators. Audit logs API is a feature that lets you see where app requests are coming from. But these are kind of things that could be used to either prevent an attack if it happens or to have some information about it after the fact. But what we really want to do is prevent it. And so with our token nuker, our goal is that this just never happens, that we've nuked it, we've revoked a token before an attacker could even use it. So friendly reminders and takeaways from this talk: don't put your secrets in a public repo. Whether they're Slack or not, if they're Slack, we'll nuke them. If they're AWS, we won't. Amazon might. If there are other credentials, there's only so much we can do to prevent you from shooting yourself in the foot. With Slack tokens, we're doing our best. Use vaults, config files, use gitignore. Don't put like config.yaml or something and upload it, and it's full of tokens and passwords, etc. Add linting rules to catch your tokens. So for Slack, they're pretty easy. It's like XOXP, XOXB, XOXS, possibly just XOX anything, depending on if you're writing XOXO a lot in your code. Maybe you're having a romantic moment with coworkers or something. But another handy tool is BFG Repo Cleaner. So this is something that will help you clean out your repos. So like I said, if you just delete the file, that's not enough. There's Git history there. There are tokens logged. And with that, thank you. We have a Slack booth here in the expo, and we have a bunch of people from the platform team to talk more about like tools, apps, etc., general Slack development. We're also launching Slack communities, so community meetups, things like that. And we have an app, like a platform conference for Slack coming up. So there's more information on that at the booth. And so with that, I don't think we have time for questions, but I'll be around. So thank you, everyone.
Thank you. Thank you so much, Max. Thanks for a great talk. OK, guys, so I just wanted to give you a really quick tip. How many of you have been out here networking? Anyone? Anyone kind of avoid networking because you don't know how to leave the conversation or struggle to leave a conversation? Anyone? Yeah? OK. So it's really very simple. All you do is you say, it's been great talking to you. I'm going to go meet some more people. Have a fab day. That is it. You do not need to pretend to take a phone call. You don't need to say you're going to the toilet. You don't need to say some crazy stuff. You just need to say, it's been great talking to you. Have a great day. I'm going to go meet some new people. OK? So remember that tip. Go have a great time. We're going to have lunchtime now back here at 10 to 1, where we've got an action-packed afternoon for you. Look forward to seeing you soon.
Time to turn on the page for the next chapter.
Never let me go.
Hi guys, please all go on stage that we can do a wonderful photo. Use the stairs on the left side, I mean this side. Ah, perfect, I have the photographer here with me. Perfect. So introduce me how you want to have all of those guys.
Would I maybe just for a second? Yeah, no, I'm not a fan, but... Okay, so guys, there's a big stage, so the core team, Stefan maybe in the middle, and the guys from the core team.
Right now it would be better to do left side.
Okay, okay, good. Good. So where is the core team? Great. Could we have some more light in the front? Okay, guys, they're good. Okay, some people can stand in the front. Second row, super. Maybe some of you can get down on the knees like this. Here's some space down there. Stefan and Stefan. Ben, where are the founders? Any founders? Founders, you have to get on the stage. You have no light here. Please use the stairs and find yourself in the middle.
Just getting in there.
Because could we get some more light down here? Just make it really bright as much as we can. Great. So. Yeah. Great. So just go back. Wow. Okay, you look fantastic. There's still someone can stand there before, yeah, in front of the monitor. Thank you. There's some space. The monitor at the box. Can everyone see me? Can everyone see me? Wow. Hey. No, I'm shy. So who can't see me has to come to the front so he can see me. There's a hand, but I need a face. Please come in front of the stage. There's some space left. Wow. Philip? Yeah, make your big. Matt, please go up on the stage. Stefan, bring him up. Matt, no, go up. No, go up on the stage. Holy. Guys in the back, I can't see you, but you're kind of in the picture. Maybe you raise your hand. I don't know. There's still space. Maybe second row, go on your knees so the people behind you. Yes. Perfect. Yeah. There's a monitor. I'm sorry. But maybe you can. Ja. Haben wir noch ein bisschen mehr Licht? Okay, no. So there's a video team. Hey, welcome. Wollt ihr erstmal? You can go first. I'm fine. There's a video team. Maybe everyone.
Stefan, wir können nicht mehr Licht geben. So video team out of scope, please.
Do we maybe have like can we fix the screen? Können wir den festmachen, dass das Logo ist?
Gerade nicht.
Okay, guys, so you just look in the camera, you shut up, you don't raise your hands yet, we do this later. I just wait for the logo in the background, I shoot, and you just smile. Great. I can hear my voice.
For the photo, that would be great.
then we go, yeah? 3. Wait. 1, 2, 3. Hands up, maybe?
Okay, hands up on 3.
Hands up.
1, 2, 3. Hands up. Perfect, guys. Looks great. Okay. Once again, all hands up and screaming. 1, 2, 3. Go! Perfect. Okay, we have it. Thank you, guys. Static Screen, dieses VR-Dingsbums nochmal geben. So guys, could you please move down? Yes. Thank you.
Thank you.
Danke. Who's missing? How many girls?
Everything worked. Thank you very much. Appreciate it. Don't know.
Okay, but it worked. Mein Adapter ist da ganz normal benutzt. Sorry guys, could you move from the page?
If we stay
Okay, but later, will be free or no?
Right now, no.
We need to spread nicely.
Ready? Okay, everyone look. Closer. Closer. Yeah. Perfect. Good. Great. Relax, smile.
Yeah, hugging, man. Come on, hugging. Do some love. Do some love here. Come on.
Almost done.
Haben wir alles? Brauchst du noch irgendwas?
Nein, das war's.
Okay. Dann können wir Lichtstimmung wieder auf Pausensituationen gehen. Und Handkeule kannst gerne ausmachen. Danke.
Nice mixture of heat, right? And everybody still vibes in, you know what I mean? They're still craving for that, beat style of original music.
Right, listen. Time to turn on the page for the next chapter.
little bit of time. Thank you for your patience. I love this tune. I'm a fire starter! Twisted fire starter! Hey, come on, let's get this afternoon on the go. Thank you. Okay. So, thank you so many of you for coming back. Thank you for your patience. We had a bit of a technical problem, but hey, we are here. We're running around 20 minutes later, so just think about that for main stage. That might actually be advantageous to you later on, depending on what kind of sessions you wanted to go to. You might now catch something you may have missed. That sounded like a disease, but never mind. Okay, so he has worked on games, game engines for over 20 years, including as the engine director of Insomniac Games for over 10 years. He has learned hard lessons about what it takes to produce some of the highest quality work in the space and what is needed to meet those requirements. He's now the principal engineer at Unity Technologies and is dedicated to democratizing data-orientated programming. He's providing greater access for teams to achieve more. His phrase to live by: don't try to solve problems you don't have. Please welcome to the stage, give him a warm welcome, Mike Acton.
All right. So today I'm going to talk about building a data-oriented future. I want to give you a little bit of background about me to start with, why I'm here. So I've been working in games for about 25 years, mostly in the console AAA space. So I've done PlayStation 1 games, PlayStation 2 games, PlayStation 3 games, PlayStation 4 games, Xbox 360, Xbox One. The last game that I worked on after about 11 years of being the engine director at Insomniac Games was Spider-Man. So from a career in working in the engine space in game development, I moved to Unity, where I no longer directly work on games. So the question is, why? For me and my journey. So Unity reaches so if we look at over the last 12 months, about 3 billion devices have run made with Unity experiences. About 29 billion installs of made by Unity experiences over that same 12 months. In about 192 countries, there are developers working in Unity. And in the last 12 months, there have been over 2 million active students learning in Unity. About 45% of the top 1,000 mobile games are made with Unity. 50% of all new mobile games are made with Unity, and about 60% of all AR and VR content is made with Unity. About 60% of the content at Tribeca Film Festival made with Unity. 65% of the interactive content at Sundance was made with Unity. And of all of the most innovative AR and VR companies, as defined by Fast Company, 90% of those are powered by Unity. Unity supports 25 platforms, or a little bit more. So for me and my journey, Unity meant impact. So what's my mission and why do I want to reach that group? There's two things that I want to accomplish. One is I want to see a future where players get the maximum value from their experience when they're playing. So if you there's an app here for this conference, right? And there's a sort of a stream complaining about the app from this conference. And my battery's being drained and it's using too much data and all the things, right? That's not you feeling like you're getting the maximum value from your experience. That's precisely the kind of thing that I want to personally address. And I want enough game developers, or just developers in general, capable of fulfilling that promise. Right? I want the world to be full of people who can do a good job with that and make sure that every player who picks up their phone, is playing a game or using an app, feels like they're getting the maximum value from that experience. So that's my personal mission and why I'm here and why I'm at Unity. What I do at Unity is lead our data-oriented tech stack development. What we're focused on is, which we call DOTS, which we focus on high-performance, multi-threaded, scalable, and optimized code. And delivering that in a way that our users, our developers, can achieve the same thing. So what problem are we trying to solve? So I like to say the problem we're trying to solve is get the clowns out of the car. If you're trying to race a car, you're trying to race this car, for instance, the problem is not how fast the engine is, the problem is not how streamlined the car is, the problem is that you have a dozen clowns inside holding it down. So before you do anything else, you need to get those clowns out. And that's what I'm focused on. The most obvious, the biggest problems that we have, the lowest hanging fruit that is just holding everybody back. So the problem is, as I see it, that the default approach that we teach, just for engineering in general, is terrible for performance. The default approach is also not optimizable. You get to a wall and there's nothing you can do. There's no fixing it. The default approach introduces problems and complexities and additional machinery, more complexity than you actually need to solve the problem. And the default approach on top of that rarely solves the actual problem. So I like to say there are three big lies in software development. Most of the time I talk about this in terms of what's wrong with object-oriented programming in particular, but it's just three lies that are prevalent in the engineering industry as a whole. And certainly also in game development. One is that software is a platform. We teach people that software is a platform, that you can reason about software independent of the hardware. And that's simply not true. There's no world in which that's true. Software is not a platform. Two, the second lie is that code should be designed around a model of the world, that you should have this model of how the world works, and you should be telling the story inside your code and ignoring the realities of both the hardware and the data. That's also a lie, because there's no world in which that produces good engineering results. Now, third, and sort of really insidious thing that we teach our students is that code is more important than data. We teach them how to code. We teach them what code is like. We teach them syntax of code. And what we don't teach them is what's important about the data that they're transforming, what the most important thing that they should be looking at is. So these three sort of insidious lies have crept over decades into the industry as a whole, and have gotten us and dug us a giant hole that we now have to get out of. So what do we want? We want performance by default. We want the default thing that you do to approximate the right thing, to approximate something that's performance, and we'll get you there. We want optimizable by default. So if it's not optimized right out the gate, if it's not the fastest thing it could possibly be right out the gate, that's fine, so long as there's a path for you to get there. Because too often you're put in a position where you write something and you've painted yourself into a corner. There's in fact no way for you to get to an optimized version of that. So you might hear somebody say, well, I'll just measure this at the end and I'll fix it. There's in real production, in real life, in real engineering, you can't just do that. There's no fixing it right at the end. One, the scope of those fixes are much, much too large for the cost and risk at the end of a production. On top of that, half the time you just need to throw everything away anyway because you designed it wrong. So two things in terms of optimizability that I want to solve for. One is I want to have no pre-production to production wall. So there's a common theme that I'll hear where people will go through pre-production, and certainly in game development, but in other developments as well, where they'll build something to see, how it's going to work, right? This pre-production. Is this going to be fun in terms of a game, or how are these mechanics going to work? That's pre-production. Answer those questions. And then they want to transfer from that pre-production work or that prototype work to production. And the only real answer they have at that point is to throw all that away and start over again. What are the lessons that we had and start over again. So it's this wall between pre-production and production. And what I want is an iterative experience. You get to that end of experimentation and you can take that and actually use it to continue on your development path. And I want no paratroop optimizers. So certainly in games, what we see is that there's a sort of group of engine programmers, generally speaking, at any given studio, that right at the end of development will try to go in and fix everything up. We'll try to go in and optimize it down to under 16 milliseconds or under 32 milliseconds, depending on if they're running 60 or 30 frames a second. They'll try to sort of squeeze all that stuff right in at the very end, and it's very difficult. It's very difficult to do because they can't make massive high-risk changes, and there's a limited number of people that can actually do this work. I want scalability by default. So one of the things that we're focused on is moving from, is looking at games that are as small as 100 kilobytes to games that are as large as 100 terabytes. So I want those choices to be available to developers, but I want to make sure that we've covered that range. And I want the fewest number of moving parts that will solve the problem well. So one of my goals is to help developers understand their actual problems and help them solve them well. So I want to make people, as they work with what we're doing, understand their own problem better. And I want to coexist with experts. So what I don't want is a world in which we're providing a solution and you don't have to think about that thing anymore. It's not a black box. What it is a utility. It's a thing that you can use, and you can focus on which parts of that you want to use. And if you are an expert and you can do some part of that much better, we want to coexist with you. We want you to be able to replace that part and do it much better. So what is the core tech that we're working on? So one is a job scheduler, a job system. So how we go multi-threaded by default. Everything that we do should be multi-threaded by default. One of the things that we've seen in games in particular is they're blocked on the main thread. You have most of the work happening on the main thread, and then occasionally you'll be able to push things off onto other threads or other cores. This is a systemic problem in design where you've designed something to be sequential initially, and there's no way out of that space. So we want to make it by default, it's able to go wide. Part of our core tech stack is a burst compiler, which I'll get into a little bit. It's a new compiler around a new language called HPC#. Our memory containers, and ECS. So I want to talk a little bit about what I mean by ECS in our context here. But first, let's talk like the sort of big picture of how all these pieces fit together. So you have your game or application. And under that, you can use a set of packages. Some of those may be ours. Some of those may be from other developers. Some of those may be your own. One of those packages is ECS. Those all, by default, run wide across all the cores available on whatever machine that you have in jobs. We have a job scheduler that works with those. Our native containers, which is the thing that allows you to reason about memory. And our dots runtime. The burst compiler is a thing that knows across the stack and will compile the code so that it works with all of this. So how does the job scheduler work? First, the critical thing is that you have to fully declare the data used in any job. There's a critical portion of being able to reason about what data is being accessed. You have to tell us what data is actually being accessed. There's no arbitrary memory access in a job. You cannot optimize that if you do that. You have to declare read-write permissions on that data. With those two things, we can do verification of correctness. We can tell you if there is a race condition, and we can have you fix it. This, in terms of actual practice, it makes a massive difference. When we look at where game developers in the industry is in general versus what this allows, is multi-threaded coding in particular tends to be an expert-level practice. When you want to optimize for that, you tend to need experts in that space. So what having the ability to give you feedback on correctness gives you is that anyone now can start to experiment in that space. If you do it wrong, we'll tell you you're doing it wrong. So you can trust say a junior programmer or somebody without that specific experience to start working in a multi-threaded space by default and get the feedback of where they're doing it wrong and iterate and start to learn how to do it correctly. And that enables just about anybody to write good, solid multi-threaded code. We also have overrides for special cases in those cases where you, as an expert developer, know what's better. We do, for instance, type-based alias analysis, and if you happen to know that these things cannot alias, you can basically cut through it and say, just let me do this. So for that, I've kind of heard it described as a sort of baby Rust. In the way that, we need to declare all these things, we need to declare these connections so that we can do verification, and that way is the same. However, because we let you sort of cut through that when you absolutely do know what's going on, it's a little bit different. So I'm going to talk about our burst compiler. Why did we choose this HPC Sharp, which is a subset of C Sharp? One is that C Sharp is already familiar to Unity developers. About half of all C Sharp on Earth is in Unity. So it's a significant part of the ecosystem. HPC Sharp is a reasonable subset of C Sharp. This is not an issue of C Sharp versus native code, because that's not what we're doing. HPC Sharp is native code. We have a compiler, it's compiling it to native code that's specific to your platform. So it's a full compiler, actual ahead-of-time compiler. So what is that subset of C Sharp that we're talking about? So it's constrained by having no class types. Anything that would garbage collect, out the window. Anything that is garbage, out the window. So no class types. No boxing, no garbage collection allocation, no exceptions for control flow. And what these tighter constraints give us is a highly optimizable language that we can compile ahead of time, and we can statically analyze your code for safety issues. It's still C-sharp-ish. We have all the basic types. We have structs, enums, generics, properties. It's a safe sandbox, even for parallel code. So you're writing C-sharp-ish code in parallel. Why didn't we just fix C Sharp? So that's an intractable problem. By design, it's poorly designed for this case. Garbage collection is not a tractable problem. Manage objects mean cache misses, end of story. There's no way around this. Boxing is bad, and just tons and tons of object-oriented legacy code that is not optimizable. So instead, we focus on the subset of C Sharp that we can highly optimize and that we can make guarantees about for our developers. So how does burst actually work? So we compile assemblies, and normally, as you're working it, as you're iterating, the assemblies get compiled normally using the normal C Sharp compiler, since it is a subset of C Sharp, and then asynchronously, burst compiles the job kernels in the editor. So it'll immediately start running in the regular C Sharp environment, and then burst will compile it asynchronously. So burst consumes .NET IL. It's an LLVM front end. Because we can do alias analysis on our memory, we can run much more aggressive LLVM optimization, so we can get actual reasonable results at the end. And the ahead-of-time workflow will integrate with IL to CPP, which is our C Sharp to CPP conversion utility. All of these job kernels can be pre-computed and pre-built ahead of time. And our in-editor inspector looks like this. On the left is all of the job kernels that exist in your game or project, and you can examine the assembly output, the IR output, unoptimized IR output, any state of that. You can also examine it per. You can change the compile options, and you can also examine it per target. So if you want to see what the assembly output looks like for ARM versus x64, you can do that. So in our view, burst in Unity is a better combination. We can do, right now we have some context-aware alias analysis. And by context-aware, I mean we know specific things about what your code is doing, because we have an integrated top-to-bottom environment. So we know how you got that memory by using our memory containers. We know those memory containers cannot alias. So we can, in fact, insert that aliasing information and push it down to the compiler. We also want to introduce a lot more static analysis, offline analysis, and that's still unimplemented, but we're working on it. We're also adding precision and determinism controls. So you can say, I want much reduced precision in, say, these math libraries because I can afford to be sloppy, or I want much greater precision. We also want determinism. Not only determinism on the same platform, so if I'm running on x64 and I'm running another machine on x64, I expect exactly the same results, but cross-platform. So if I'm running on an ARM device, say my iPhone, and I want a server running and I want that server to produce exactly the same results as my ARM, then we're going to guarantee determinism across these two devices. We're also going to introduce higher level SOA to AOS conversions, so structure of arrays to array of structure conversions. This is normally a super manual process for programmers. Excuse me. A super manual process to redesign the data and transpose it based on a case, on your specific case. And so what we're trying to do is introduce the concept of you could just transpose that data with a switch and experiment with what's the best possible layout for you. And with all of this, we get Unity code iteration times. So as you're editing your HPC# file, it gets put into the editor, it builds, it runs, all of that. It's available inside the editor. It's available in part of your iteration loop, and for our target is under 500 milliseconds. So there's no long build wait times. There's no big link time for me to see the result of that in my editor. So our memory containers, as I mentioned before, no garbage collection. They're we support custom allocators for common use cases like temp and temp job with lifetime and access rules. The key to our memory containers is that we have good aliasing rules by default. By default, we're saying these containers cannot alias. That's understood by the compiler, and therefore we can spit out that information to LLVM. Therefore, it can give us actually good results at the end, which is something, if we compare it to, say, C++, something that's not possible in that scenario where you have an unknown source, the compiler doesn't know where that memory came from, cannot do an aliasing analysis based on two separate pointers, doesn't know that they could possibly not point to the same thing, which is why, say, the restrict keyword was introduced. However, there's no possible practical way for you to introduce restrict across your entire application anywhere that could possibly poison that data. We can do that. So, what does ECS bring us? It brings us a good, for ECS, we want a good default data layout. We want a good default transformation pipeline. We want a good data iteration experimentation workflow, and we want it to be optimizable. So a quick background on what ECS is. So in sort of typical object-oriented space, you have game objects as a container. It's a class that has a bunch of stuff in it. And it looks like this. They're each individually heap allocated. You can imagine each one of these is an individually heap allocated game object of various pieces of data, and they're just all over memory. ECS is different in that an entity is just a key into data where the data is homogeneous of a specific single type. So it looks more like this, where each one of these things is a set of types, and it's a structure of arrays, basically, of the individual component types. So if we look at this and divide it into, if we look at this, each of our types here, divided into separate individual chunks, what we call an archetype is the definition of the combination of specific components that you might have. So an archetype is a set of types. Like if you have position, rotation, render type, and a rigid body type, that's what we call, that combination is what we call an archetype. Chunks are currently a 16 kilobyte block of memory, structure of arrays of all the types that you have in that particular archetype. We have a concept of a query, so you can request a specific set of types. So I'm requesting these two colors, for instance, and it says these are all of the archetypes that match those two colors. It can gather them up, gather up all the chunks that belong to them, bring them all together, line them up, stitch them together, so that you can process a work kernel across the specific types that you've requested. And that work kernel runs inside of a system. So basically the two concepts that we have are the components and how the components are laid out in memory, and the systems which run across those queries. We have worlds for isolation. Conceptually, this is how a job component system works. You basically are launching, you have a management thread, which is the equivalent of your main thread, which launches a bunch of systems, and each one of those basically by default goes wide across as many cores and worker threads as you have on your machine, and those all get stacked up. So let's talk about, that's the background of what we're doing. So I want to talk about what are the principles behind what we're doing, and a little bit about what data-oriented means. So what are the principles of data-oriented design? So first is that the global energy required to transform some data should be proportional to the amount of surprise. And what that means is if you have an event that's not surprising. So for instance, if you have a frame in a game, this frame and the next frame of the game. The next frame is guaranteed 99% of the time to be very, very similar to the previous frame. Most of the work that you do in the next frame is unsurprising. So it should be proportional to that fact. You should be, in fact, doing less work in order to provide that second frame. By comparison, if the camera had completely moved across the world, right, then the second frame would be completely unrelated to the previous frame and should be doing more work in that case. So it should be relative to what's surprising. So as an example, like think about where you keep your toothbrush. It's unlikely that you keep it in a drawer in your kitchen, right? Most likely scenario is that you keep your toothbrush next to your bathroom sink. Why do you keep your toothbrush next to your bathroom sink? Because it's unsurprising that you're going to have to brush your teeth. You know for a fact that you're going to have to brush your teeth tomorrow, tonight, whatever. So you prepare it and you put it very close to the place where you know you're going to have to brush your teeth. So the amount of energy you need to put in to get your toothbrush is proportional to how surprising it is that you're going to need to brush your teeth, right? So the opposite of that would be you store your toothbrush under your bed, right? And every time you want to brush your teeth, you have to go get it. But the fact is that that's how we program. That's how, by default, we program. People put their data in a place that's far away in terms of it's not in cache or it's in memory, it's on disk. They put their data in very far away from when they actually need it, even though they know they can guarantee that they need it. And when I talk about global energy, I'm looking at it, in fact, globally. So I'm looking at our Unity work at Unity, times the number of developers using Unity, times the players that are playing those developers' games and applications, times the time that those play sessions are happening. So all of that energy, actual energy usage, practical energy usage, whether that's energy being pulled from this power cable on my laptop, or it's on a battery on device, all that energy adds, everything impacts that energy usage. And I would like to reduce that. So the next principle is the purpose of all programs and all parts of those programs is to transform data from one form to another. This should be intuitively obvious. A computer literally cannot do anything else, right? It gets inputs and it gets outputs. A game is basically an input and output machine. There's controller inputs, and the output is the screen and the audio. And it's hierarchical from there. Some piece of that is inputs and outputs and does something. Some piece of that is inputs and outputs and does something. That's literally all a computer can do. And yet, somehow, we're taught to do something different. We're not taught to transform data and understand the transformation of the data. What we're taught is to tell a story with code abstraction. And that's not what we need to accomplish. What we need to accomplish is transforming that data with the least amount of energy that we possibly can. But let's talk about abstraction a little bit. So there's two kinds of abstraction when I think about abstraction. One is utility abstraction. So this is scaffolding. So this is I'm giving you a tool to do something, and you could use that tool or not. So for instance, a light switch in my house is utility abstraction. I could not use that light switch. I can take the light switch off and I can wire those two wires together, and that's fine. It's not actually hiding any information. It's just making it more convenient for me to do a specific activity. Then there's a second kind of abstraction, which is storytelling abstraction, where in fact I am trying to hide what's happening with the data, where I am trying specifically not to inform you about what's happening behind the scenes. And between those two things, one of those is useful and good, and the other one is really, really not. The next principle is that if you don't understand the data, you do not understand the problem. So in terms of understanding the data, imagine that if I say, I'm going to give you a deck of cards with integers on them, and I want you to sort them, or I want you to add up the numbers on these cards. And you can think about how you might do that. And then I say, okay, well, what if there's only 10 cards? How would you approach that problem? What if there's 1 million cards? How would you approach that problem? What if there's 10 billion cards? How would you approach that problem? What if 99% of those cards were 0? How would you approach that problem? Almost all of those questions, all the answers to all those questions would be different, completely different. In fact, in each one of those cases, you're talking about essentially unrelated problems, that the solutions would have very little to do with each other. Even though the mechanics of adding or sorting are similar, the actual problem solving is very, very different. The solution looks very different in those cases. So you need to understand the data, or you simply cannot solve the problem. And conversely, you need to, in order to understand the problem, you can inspect and understand the data. And this is trivially demonstrable in any code base. Pick any function in your code base and capture the data in it. Dump it out. Look at it. Actually examine it. There's inevitably something that you can learn from that. Inevitably something that's going to surprise you. Different problems require different solutions. Programmers love three things, in my experience: generic frameworks, platform independence, and future-proofing. No. Let's say no to these things. So generic frameworks is implying that I don't want to know anything about this problem, and I want to hide all the things about this problem. And in fact, not only do I want to do that, I want to kick it down the road for somebody else to solve. And you're not actually going to solve the problem. So what I don't want is generic frameworks. What I want is utilities and standards, things that people can actually use. Platform independence is not a thing that actually exists. You cannot be independent of the platform. That makes no practical engineering sense at all. What you have, though, is platform commonalities. You have some platforms that are very similar, that share similarities, and you can combine those similarities. That part is fine. Future-proofing is another example of something that doesn't actually exist. You cannot future-proof. You cannot solve a problem that you can't possibly know what's there, what anything at all about that problem. So you need to solve problems that you actually have, or that you have the experience to anticipate. There are problems that you can anticipate. Those are fine. And I'll add this tweet. The only future-proof systems I've seen are systems that are easy to delete, which I heartily agree with. If you have different data, you have a different problem. So if you catch yourself thinking, I'm looking at a problem, well, what's the best way to do this? Generically, abstractly, you're thinking about that. The answer is inevitably, there isn't one. And what are you measuring? And you need to stop, and you need to, if you catch yourself saying this, you need to stop and look at your data, because that's going to help you answer your question. There isn't a best way abstractly. There's no abstract version of this problem. You need to actually look at your data, actually examine it, and that will help drive what the actual solution is. If you don't understand the cost of solving a problem, you don't understand the problem. So if I'm sitting down and I'm saying, okay, I have a problem in front of me and I'm trying to solve it, I'm trying to create a system, or I'm trying to create a feature, and I'm trying to reason about how this feature is going to work, but if I haven't thought about what the cost of doing it is, then I can't possibly understand it well enough to solve for it. And there are four things in particular that we reason about that I think every problem needs to reason about, and that we want to build tools to help people reason about. One is performance constraints. If you're not reasoning about what the performance constraints of any problem you're working on are, you're not solving the problem. You simply cannot solve the problem well. So whether or not it has to fit in 1 millisecond or 10 milliseconds or 10 minutes, it doesn't matter. The fact is that it has constraints. So whatever you're thinking about, whatever problem you may be working on, if you think, well, I haven't thought about the performance constraints of this problem, then you think, well, it doesn't really matter. For whatever I'm working on, the performance doesn't really matter. That's, in fact, never true. Because if we took whatever you're doing and we said, I'm going to multiply by, it's going to take 10,000 times longer to do it. We're like, well, obviously, that's not good enough. Like, obviously, it has to be faster than that. Okay, well, then there is a constraint. What actually is it? Find that number so that you can stay under it. Second is determinism constraints. Do you want to make sure that this thing is repeatable? Scalability constraints, how big, how small, how many? And workflow constraints. UX is part of designing a solution for any problem. If you don't understand the hardware, you can't reason about the cost of solving the problem. So this is what I mentioned. There's no such thing as a software platform. That makes no sense. Everything that you have runs on some hardware somewhere. And you have to be able to reason about what hardware it's running on, at least at some level. And so somebody might say, well, it's obvious. It's obvious it's going to work. It's obvious. It'll be fine. Well, is it true? Is it truly obvious? Like, is whatever you're working on going to run on an NVIDIA GPU? Will it run on an ARM device? Will it run on a Pico 8? Will it run on 10,000 distributed x86 64 cores? Will it support SSE 4.1? Will it run on the iPhone or on the Android? These are all platform and hardware questions that must be answered as part of designing any piece of software. So can a compiler figure this out? Can I just do whatever? Well, let's talk about some specific case. The answer is no, but let's talk about some specific issue around a common x86 64 core. So if we look at what people normally would consider expensive, which is a square root instruction, it's somewhere in the range of, say, 20 cycles on a very fast machine. But if we look at the actual memory access times, what we see is it's basically 3 cycles-ish to get data from L1, up to more than 200 cycles to get stuff from main RAM if you have an L2 miss. So what does that look like? So if I have something in memory versus something that is an L2 miss. So L1 in L2 in L1, great, fast. In L2, not as fast. And if the memory I need is not an L1 and not an L2, and I need to go to RAM, what does that look like? Right. So L2 cache misses per frame are very likely to be your most significant component, the most significant thing that you need to concern yourself with as an engineering issue. So let's take a really quick example. Imagine this is a game object, or a game object like this that has some function, the method like this, which is just multiplying a couple of things. And imagine this is heap allocated in a very traditional object-oriented way. So what does that look like? Here's the code of that function. What we see is, you see a 2 by 32-bit read here, which are, let's say, are on the same cache line. It takes about 200 cycles. We do our floating point mul and add, which is about 10 cycles. Let's assume that the square root is inline, and that's about 30 cycles. And then we do our multiply back to the same address, which is now an L1, so let's say it takes about 3 cycles. And then we read and write the new line from the next line, which takes us about 200 cycles. So the point of that, looking at that, is the time spent waiting for L2 versus doing actual work in this function is about 10 to 1. That 1 is the compiler space. That 1 is the space the compiler can fix. So if we look at it a different way, this first line, we wasted 56 of 64 bytes. You're reading in cache lines. There's no way around it. That's how the hardware works. We wasted 56 of those 64 bytes in that read. If we look here, we wasted 60 of our 64 bytes in the next cache line that we needed to read, which amounts to about 90% waste. This is waste of actual energy and actual things that are actually happening on the hardware that we're dealing with, which means everything, by nature, is about 10 times slower than it needs to be, just for doing nothing. So you can also think of it as 10% capacity used. That doesn't actually mean 10% used well. On top of that, there's additional optimizations that can be done. But this is pure, these are the clowns in the car. This is pure 90% waste for no value whatsoever. And this particular thing is why we have organized our data in this format, in this structures of arrays in chunks, so that by default, things are getting loaded in this form. Everything is a data problem, including usability, maintenance, debuggability. Everything is a data problem. Measure it, figure out what you want to improve. So what we want to do is give everyone the tools to understand what they're doing and fix mistakes. We want to help build experts, not replace experts. And solving problems that you probably don't have creates more problems you definitely do. So this speaks to building abstractions. Every abstraction you make is another set of problems for somebody else. Like, you're going to invent something else that now somebody else has to understand. And they have to understand all the edge cases and all the weirdness that you've created as part of your abstraction. On top of that, they have to understand the thing that the abstraction sits underneath. And on top of that, they have to understand the hardware. Every abstraction you create creates problems. So you need to minimize the actual abstractions. The more context that you have, the better you can make a solution. So, for example, Burst has context about where memory is. That's the advantage of Burst. We want to help developers build tools to take advantage of what they know and we can't know. So, overall, what I want to talk about what I mean data-oriented design is it's not magic, it's engineering. We want performance by default, and we want optimizable by default. Thank you.
Thank you so much, Mike. Hopefully everybody that was useful, because I know he gave you a lot of tips. So we are just now going to, so let's just give him a clap as he leaves the stage. And what we're going to do is we're literally going to take a couple of minutes before we get Shirley set up, and then we will be back straight away. Thank you. Let me go around. Okay, so, it's been an interesting afternoon. All sorts of techie things going on at a tech conference. So, our next speaker gets to do the things she loves: code, art, and storytelling. And she does it with really great people. She is a freelance software engineer specializing in data visualization and combines her love of math and code into colorful, interactive data. So a little known fact about her is that when she was a kid back in Japan, she used to get around on a unicycle. Who knew? So her one phrase to live by is, "I'm all in or not at all." So please, welcome to the stage, Shirley Wu. Please welcome her.
Hi, everyone. Wow. This is such a huge room. Thank you so much for being here today. And thank you so much to We Are Developers for bringing me all the way out to Berlin. My name is Shirley, and I'm an independent creator of data visualizations. I started out as a software engineer back in 2012 at a big data company, where I first learned the JavaScript library D3, and I learned how to create data visualizations with them. And I love that so much that for my second role, I decided to take a front-end dev position working for a data visualization product. And in 2016, I decided to take the leap, quit my full-time job, and try my hand at freelancing, only doing data visualization projects. And for the last 3 years, I've had the great pleasure of working with a variety of clients, mostly across the tech, media, and journalism industries, helping them tell visual stories with their data, as well as a personal project called Data Sketches with my great friend Nadi Bremer, where we create 12 different data visualizations on topics of our choosing and write about our process from start to finish. And today, I want to share with you some of those past projects over the last 3 years. But more importantly, I want to share with you the many, many lessons that I've learned creating those projects across the whole data, design, and code process. So let's get started. When we start any data visualization project, the very first thing, of course, is to go out and get that data. And through the years, I've found that, at least for my own projects, it's very important for me to start out with a curiosity, a topic that I'm so interested in that that curiosity will motivate me throughout the whole project. And I've also found that with that curiosity, I can really get creative with my data gathering to answer my questions and satisfy that curiosity. Sometime in the middle of 2016, I was really, really obsessed, very obsessed, with this one musical called Hamilton. I don't know if anybody in the audience has heard of it. It's a very, yes, thank you. It's a very American musical. But I was so obsessed with it that I listened to it on repeat for months on end. And it got so bad that I was like analyzing all the lyrics, and my fiance was like, "Why don't you just make a data visualization about it?" So this is an interactive visualization of every line in Hamilton, where each of these dots represent a set of lyrics sung by a character in the musical. And as the reader scrolls, I present them with all the analysis that I've done and all the insights and interesting patterns that I've found, until they get to the very end, And I share with them the exploratory tool that I use to do my own analysis, where they can filter by any set of characters, conversations, and themes, and dig into all of the remaining lines and songs to do their own analysis. And this project really started because I had this curiosity, two curiosities actually. And the first question was, how do the relationships change between these characters throughout the musicals? And two, what recurring phrases are there, and who are they associated with? And you can probably imagine that none of this data is available out there anywhere, at least digitally. So I had to go through all of the lyrics of the musical by hand, noting any of the recurring phrases and any variations on those phrases, grouping all of those phrases into broad themes, and then manually going through the lyrics again, entering them into the computer, and noting any characters and conversations. And then I wrote a script to aggregate all of that metadata by song and line number to get my final data set. And this project, along with many similar ones, have taught me that as long as I have a curiosity, I can go out and find the data I need to answer all of my questions, whether it's through manual entry or automated scripts, as long as I stay within the boundaries of the law. Now that we have our data, the very second thing I've learned to do is to always explore that data before starting on the design. This is a project I did for Data Sketches called 4 Years of Vacations in 20,000 Colors, where I took 4,000 images over the course of 13 trips, pulled out the 5 most common colors in each of those photos, grouped those colors by the trip that they were taken on, and arranged those colors by the day of the trip that they were taken on. And this project is one of my personal favorites because I learned a lot about myself through this project, which is that I've always known that when I'm on vacation, I really like taking pictures of nature. So all the waters, the lakes, the oceans, the mountains, the trees, and all of these greens and blues made a lot of sense to me once I saw the visualization. But I was really confused as to why I had all those reds and oranges. And when I took a look at the underlying photos, it turns out they were all food photos. So it turns out this trip to Japan back in 2014, apparently all we did was eat. And then this one was to Iceland, so there was quite a few beautiful lakes and glaciers. So yeah, this is one of my favorite projects, personal projects. But the project didn't actually start out so well. This is one of my first very rough sketches once I had collected my once I had collected my data. And I had really good intentions. I really did. I wanted to understand where and when I was taking my pictures. So on the x-axis, I have the time of day that the pictures were taken on. And then I extended that, and I kind of wanted to see which continents maybe I was taking the pictures on. And on the y-axis, I wanted to map the year that the pictures were taken on. I had really good intentions. But what happened was I had collected all of my data, and it took so long. I was so exhausted. I was like, I don't want to look at the data anymore. So I had zero understanding of what my actual data was. Zero understanding before I started sketching this design. And so when I actually went to the code part and executed this design and put my data onto the screen, this is what happened. I'm now quite fond of this piece. I now lovingly call it my art piece. I call it a man peeing into a puddle. Yeah, I've grown attached to it. But it's not a data visualization piece that I could have published, so I went back to the drawing board, I took a step back, and I asked myself, okay, I really need to understand my data. So what metadata do I have? What metadata does each photo, each data point have? And I saw that I had the data of the trip that each of these photos was taken on. And so I thought maybe I can group each of these colors by the trip. I had the day that it was taken on, so I decided to map the date to the angle so that the colors were kind of arranged